Yeah, we're live. 4 seconds in. I'm just gonna let it load for a second. Hey everyone. I see some folks filing in already. Welcome back to Octopus Odyssey 2. We are super stoked to have you all join us this afternoon. The Octopus Odyssey crew is back, ready to collect experiments, explore some more octopus ecology. We've also got geologists, chemists, microbiologists, so we've got an amazing watch schedule lined up for all of you this expedition. And currently we are at Dorado Outcrop for the second time, Dorado Outcrop 2. And without further ado, our watch lead right now is Dr. Beth Orchid, and she will be taking over the narration today. So over to you, Beth.
Thank you for getting us started. Hey everybody, this is Beth Orchid from the Bigelow Laboratory for Ocean Sciences. It's a real pleasure to be back out here with Schmidt Ocean Institute for Octopus Odyssey 2. We were here in June of 2023. We are now back in December 2023. This is one of our largest octopus nurseries that we're about to start looking at. We can, just over here off to our port side, we're about to start a qualitative look to see how many octopus are here compared to our visit in June. You're going to see some markers come into view that indicate where some experiments are that we're going to be picking up on this expedition to understand the fluid chemistry, the temperature of these hydrothermal springs, and then we're going to start to zoom in and see, are there any baby octopus at this time of year? That was a big excitement for June of 2023, but we don't yet know what we're going to find. So stay tuned, send us your questions, and hold your breath. But not too long. Yeah, so what are we seeing here? We've got some sponges, and now we're starting to see these octopus in what looks like brooding positions. Maybe a few males. Okay. That's fine. It's fine to go. It's fine to go as you're doing it. And then we can just come back by the other way. However you want to do it. Got it. This is okay. So now you're starting to see one of our first markers come into view. There's a couple in this spot. Those markers indicate places where we previously detected venting hydrothermal springs. See, there's looks like a cutthroat eel maybe. Checking out the scene. Looks like a couple of octopus are not in the brooding position, but in a mobile position in between some of our experiments that are deployed there. That looks like another potential male out there on the bottom right. And backing up a little bit. Looks like there's... That's the other one? Okay. There's that giant tube anemone Looks like there's two octopus engaging in some discussion right there in the middle of the screen. This is great, yeah. And then let's come back to port a little bit. Right, here's our other set of experiments, which I believe is marker R, yep, and W. Potentially, I don't remember off the top of my head. We usually would see some. So that's entirely possible. There should be other markers in this area. So yeah, we can go ahead and back up and see what those look like as well. Give us this quantitative view of the land before we sit down to pick up our experiments. Can we put up a picture-in-picture of the map, Sophia? Just to show our audience where we are. No, we can go back up to the waypoint. We're going to do that at that site. Thank you. I'm realizing I should probably give you guys the waypoints for the other markers, even though we're not going to them, just so we have them in the map. So not this one, but the next one. Oh, that one. You can definitely tell that marker R has got some vigorous venting going on. I can see the shimmering even just as we're driving by. Okay, so what we're going to want to do is set up to kind of sit here and be able to do some zooms on the octopus and then be able to take out the high T probe and hold it over, for instance, this wood bag. Although animal shelters don't seem to be colonized, so we might not be recovering them, but we might be moving them out of the way. And then, like, for instance, these little Jimmy Jams, we want to take some temperature measurements around them before we pick them up. So however you think you want to sit down to be able to do that. And we don't have to do it all in one go. So if we need to reposition. Yeah. I don't know if it's easier to do that while we're hovering or if you want to sit first.
Probably going to be easier to first have a peek around.
It's like right on the...
Yeah. There's some, these look like they're exposed right here.
I could probably get some free fly first.
Okay.
And then...
Yeah. Yeah, on the left. Do you mind if I fly the camera? Okay.
I might have you zoom in.
Yeah. Okay, fair enough. Yeah, it was just a moment ago. But there's also some in the little clutch to the left, behind the marker. They look milky, but I don't see any eye spots. So for anybody new to this footage, if you haven't seen these dives before, the octopus in this position with their legs out are most likely females brooding eggs. We think that they're attracted to brood here in these warmer waters. We're going to do some temperature measurements here a little later in the dive. It'll probably be about 12 degrees.
There's a CPAN on the tripod.
So those eggs, so far I haven't seen any eye spots in them, but let's, we'll wait. Okay.
There's one just right below me.
Yeah, if you want to pull the RAM out too to help, not the,
Yeah, I was
yeah.
trying to find one that we're able to see, instead of laying out and
Sure.
not being able to see that. That one seems like it's a good option.
Or if there's an ability for you to hover and I can just move around and look at them.
It'll get a little tricky.
Okay.
With two zoomed in.
Yep.
But if I can find a good spot, we can do some cover and find the one that's behaving the most. These two seem like they're the best candidate, right? Would you agree? Those two?
So this one we can see them, this one, and also, where did it go? There was one over here that we can see one.
I can park right there.
Okay. Yeah. Take your time. So while we're getting set up to take some closer views, you might be wondering, what is all this stuff? This is not trash. These are science experiments. So the net bag in kind of the right-hand corner is full of wood blocks to study animals that colonize that material, organic material. In the center of the frame, you see some little PVC tubes with a dive weight underneath. Those contain some different types of hard substrates to see what kind of microbes colonize rocks and other substrates down here. We also have temperature sensors here and an experiment to collect samples for measuring chemistry of the fluids. Thank you. It's not responding. What am I doing wrong? There we go.
An MTA.
Yeah. I guess that's the closest zoom I've got.
I can bring it a little bit closer.
It's okay. Can you take some frame grabs, please, Rue?
Yes.
And can we get the lasers on for just a moment? I might be too zoomed in to see them.
That's what we're working on to try to get it to be quite zoomed in.
Okay, so now we can see the lasers at the bottom. You could take another frame grab, please, Rue. Could potentially be something in those.
Those definitely. Apart from the eye spots, it looks like they have arms there, and there's one open, potentially hatched.
Okay.
But that clutch looks different.
Yeah, that one just looks like a milky.
Whereas that clutch looks like
Yeah. We potentially. So yeah, they could be. We really don't know about these octopus and their ecology in terms of when they lay their eggs, if they do it all at the same time, if they come and go. So that's what we're trying to see. Are there any eggs back here that we can see? Not yet. Okay. Looks like yeah, they're all, not surprisingly, the moms are protecting their eggs from predators and from voyeurs like us. A lot of shimmer. So as we go through our operations, we'll probably, some of the octopus might move around a bit, so we'll just be keeping our eye out to see what's going on. You can turn the lasers off now, thank you.
I want to blind the mamas.
Well, I don't think the lasers is really what. Yeah, I'm not. I think there might be stuff in some of those eggs.
looks like little leggies. Sort of tightly curled.
What you doing down there, Mama? Let us see. Okay, how are we doing on time? So
But it potentially be ones that have just recently hatched and are about to.
or they were snagged by a predator. You never know. Okay, so we've done this. We've done this. Diva, you want to hop in here for a few minutes?
I was trying to see if give you a different view.
Oh, yeah, I see what you're saying.
Snap bracket for a minute.
Yep. Somebody's hungry. Okay. You're going to be hearing us for the next few days as we explore. Stay tuned. My colleague Diva Iman is going to jump in the hot seat here for the next little bit. You're going to hear some new voices on this expedition series. You're going to cycle some of them in today. So thanks for tuning in. Of course.
So good afternoon, everyone. Buenas tardes todos. We are here on the seafloor at about nearly 3 kilometers depth, and joining us in the control van right now, my name is Dr. Diva Aman. I'm from Trinidad and Tobago with an NGO there called Species, but also with the University of California, Santa Barbara. The data logger on shift right now is Ru Akiba from the Department of Earth and Planetary Sciences at the University of California, Santa Cruz in the US. And we've got our 2 RV pilots right now joining us, J-Rod, Jason Rodriguez, and Claude. And we also have our media technician, Sophia, who's here as well. And so we just got to the seafloor. I'm going to be with you. We're going to be with you for the next, or I'm going to be with you rather, for the next 10 minutes. And this is the first time we're back since June, and we really are just trying to get a view of what is down here. Octopus eggs hatching, and now we're trying to we can see any eggs and whether we can see any babies within those eggs. It's pretty inconclusive. It looks like perhaps the left clutch might have, right? And on the right clutch, those look emptier. But this could be just about different developmental stages, like Beth was just saying. So we've got and so what we're going to be doing next is maybe, do you want to move? And we can try to see a few more egg clutches, because we have another 10 minutes. Or do you just want to get into the measurements?
Yeah, if it makes sense to reposition to get a couple more shots, that's fine.
Is that okay, J-Rod?
Yeah, I can always
Let's take a few more looks.
I kind of just want to see what my sample would be like and then do the sample here, which, you know,
Right. So we could also, if it makes sense, to bump work operations
Yeah.
to do some temperature measurements while you're set up, and then hop over.
Yeah?
Do some
yeah,
more.
that kind of.
Let's do it.
I'm just looking at this. We can get to that bag and some of this stuff here. And whatever we can't, then we can.
Exactly. That makes sense.
So if you're up for it, then let's do some temperature measurements around the two animal shelters, the CVC pipe and the clay pot. We can move those aside. Do you want to move them?
Yes, we will want to move them because if we want to clear the area for that doing detailed
All
stuff,
of the things, yeah.
So it doesn't look like they were colonized.
No.
Okay, so we're moving the things before we go for tip 3?
No, sorry. So all of the things here, this, and this, we want to get a temperature measurement of it in situ. And then we will be picking up different things and stowing them or moving them. Like, we don't need this necessarily right now, but we can pick this one up. So yeah, we're like doing temperature measurements, and then we're gonna pick them up.
Okay, so we can start.
We're not picking up the wood.
That is correct. I'm sorry, we're not picking that up, but we can still move it out of the way.
Yeah.
Once we do our temperature measurement. And
So last time we were here, one of the hypotheses was that these octopus moms that we're looking at are using the fluids that you just saw seeping out of the seafloor because they are warm and chemical rich. Last time we were here, we measured temperatures around 12 degrees was the max, which may not seem like a lot to us, but actually it is a lot down in the deep sea where ambient temperatures tend to be 3 or 4 degrees Celsius. So we're going to have a look at what the temperatures are now around these experiments in particular, and then collect them. We were hoping that one of the experiments we were testing was whether the octopus moms would find homes in the PVC pipe or the clay pots, but instead we can just see there's a sea pen on the clay pot instead, which, we'll take it.
Do you have the temperature reading? We need to be able to see what the marker number is before we start measuring, or are you good with us just going into it?
We can see it's W marker. So I think, Ruth, you could just make a note that it's W. And I'm not sure where the temperature measurement... Oh, perfect. Okay, I thought it was up already. Okay. Great. No, we got it. Thank you. So temperatures are around 2 degrees, which is ambient in the deep sea. That's great. Thank you. While you're here, we can, I think, shove it to the left as well to see what temperatures we're getting there, just as contrast when you're finished.
Yeah, whatever you
Are you
happy with that reading?
Yes.
yeah, so
that was.
You want to write down the ambient temperature measurement.
So if we could go up here next.
Was
I might have to.
Oh, if you don't have.
No, I might just have to pull my arm. I'm just going to slowly pull it right now. You said I'm not going to hit any of those guys.
So while we're setting up to do another temperature measurement, the community of animals we're seeing is not very different to what we saw last time, at least that's how it appears superficially. We've got lots of octopus moms still sitting within the fluids, and then around them we can see some species of shrimp within the fluid as well, some sponges off to the left. There's even a tiny little chitin up in the top left corner, or polyplacophoran. Okay, 2.6. Going a little higher on this one. Yeah. So again, 3.8. How this amazing and very unique habitat work. So are these mother octopus dependent, and some of the other animals here, are they dependent on these warm and chemical rich fluids? Do the fluids have microbes within them that again the octopus and many other animals here rely on? And how are those microbes in the fluid also contributing to the formation of the seafloor and the crusts? We're also going to be doing quite a lot with fluids on this expedition, measuring the fluids that are coming out, measuring what's in them, and looking for areas where, again, this is a unique place where...
Is it possible to get it down in the pot?
This is a really unique area of the seafloor where in around Dorado area, not this particular outcrop, but where we know fluid comes out and also fluid goes in, which we'll talk a little bit about on those particular dives when we're exploring them. But this is only one of a handful of known deep sea octopus nurseries worldwide, and so this is a really special place, not just in Costa Rica, but globally. Okay, so yeah. Okay, and then if we could just measure by the pipe. I'll just do 2 more minutes and then we can.
And then you said to the pipe?
And then by that pipe over there, please. The elbow.
Yeah, rotate.
Oh, 2 point, okay. This one's going a little higher. So this one we go on 2.64 at the elbow.
Yeah, you can see it like pulling through it.
Yeah.
All right. Is that good for that?
That's great, thank you.
And then?
And so now we would like to, do we just want to recover some of them straight away? Or would you like to? Recover the animal shelters.
The clay pot we don't
And-
want, but we want to just move it out of the way.
Okay.
The PVC pipe, it looks like the octopus might be in it, so we can maybe, I don't know, maybe it's on the other side.
Okay.
Either way,
Okay.
if we don't, we're going to pick them up.
And move them
Doesn't
to
look
the
like
side.
there's anything in them. We're going to move them to the side. If there's something in them, we're going to put them in the bio box 3.
Okay.
and
And then the microbe trap
And
is
then we'll do
definitely
the
coming on.
microtraps,
Okay.
yes. And there's several of them, so we can't see the other ones in this view. This is just one.
Yep.
Yeah.
There's
I think they're
more
right.
over here. So
Okay.
we'll pick up what we see, like there's one right over there.
And temperature measurements by
We want
measurements.
to do the temperature measurements of those before
Yep.
we pick them up.
Sure.
So yeah, just whichever one you want to start with. Like pick this up, is there anything in it? No, move it over. Pick this up, is there anything in it? No, move it over. Move this over. And then we'll pick this up and recover it.
Yeah. I don't know, J-Rod, whether while we have the temperature probe out, hold on, while we have it out, we didn't do a measurement by this one. Can you reach that right now? Or this one? Because if not, then we'll just...
Okay.
So
Think you can reach some of that type of
and this, while the probe is out.
The one that's way over there, probably not.
Right.
Maybe that one right there. I guess I could always bring one on back out. And then
Some pretty good manipulating.
Is that close enough?
Yep, that's great. Thank you.
There's nothing in these animal shelters.
Yeah, note down that reading. Highest on that one was 2.34 as well.
Okay.
So there's nothing in it, we're just moving it
I
on the
can
side
potentially
to clear
pull
out
myself
the
away
area.
and maybe get
Then
the
we're gonna pick up.
It's just I was just thinking about the order of what would be easier
Biobox one is
for you, but
rock. And that's
Yeah,
supposed to be
yeah, I'm just gonna bring my RAM out now. Alright, go.
ooh,
I'm back on right now. Let's go and stow that thing. Start? Yeah, let's go.
and then we can just begin to move things.
So you picking up the feedback?
So no, so we are pick. Tell me what order would be easiest for you guys. We need to move the clay pot out of the way. We need to move this bag out of the way. We're going to be potentially collecting this if that octopus is actually living within it, and we're definitely going to be collecting this. So it depends on what order is best for you guys. Also collecting this
Yeah,
and
but-
this
The collections are pretty easy.
and this.
Yeah, I mean, it looks like collecting won't get in the way of everything.
Okay.
Hey, you wanna collect first? Hey, just tell us which one you want us to do first then.
I mean, we can try for this one first.
Okay.
And if we do manage to collect that, that's going to stow into Biobox 3A and B, or 3A or B. If the octopus is not within it and not attached, then we're just going to leave it onto the seafloor out of the way.
Yeah.
Yeah.
So pick it up and move it.
Yeah. But these, this, and this will definitely be coming on board no matter what. And those will go in Biobox 1A.
Alright, so go for this,
Smoke first, yeah?
not the blue one, the yellow one.
Yeah.
Yeah, they'll come in hot.
He's not happy. So there was some recent work by colleagues off of California at another known deep sea octopus nursery, and that showed that there are these males, which is this individual coming in at the bottom here, and they tend to have harems of females, which are all in the brooding position. Another egg down here that doesn't look like it has anything in it. And at that site, it was determined that, again, the octopus are nestled within this warmer fluid, potentially accelerating development of eggs. He's not happy we're here, potentially.
Or he's just touching us to say hi.
Or, sure. Or he's making contact. Oh.
Right.
So how do you want me to come up with it if there's nothing in it?
So if there's nothing in it, I mean, just stow it any sort of
Okay, so come all the way up
safe-ish
no matter
place.
what.
Yeah, she's not in it. Oh. She's not going to leave her eggs, I don't think.
So it looks like the eggs behind her are also pretty new.
Push that.
Oh, eggs.
Yeah, So this has given us a little glimpse of eggs, and there are 2 empty eggs we can see there, unknown whether they were hatched or predated. But there were some other eggs behind her that did not look as potentially developed as we've seen others. So yeah, if we just hoist it out of the way. So that is a very clean looking PVC tube. No eggs, no adults.
So we can put this in.
So
Yes.
I'm going to leave you in the very capable hands of Maria Sandoval from the University of Costa Rica, but she'll introduce herself. And yeah, stay with us for the next sort of 10 hours or so. Okay. You heard. But so we're here. We've measured the temperatures at the majority of the traps in this area. None of them have any animals, so we're just going to hoist them out of the side and put them
Where?
next to
There?
anywhere out of the way. We are going to collect some of Gus's microbe traps. Yeah.
But all of them, they are going to biobank?
Yeah, I think they're all going to the
All
same one.
going?
Yeah.
Okay.
The microbe traps. And then, well, we can confirm that.
Yeah.
And then there were 2 others of Gus's micro traps, the 2 further away, that one and that one I think,
Yeah.
that we haven't done temperature measurements at yet. So when they turn and reposition, we'll need to do some more temperature measurements at the micro traps as well.
there.
2 others before we collect
Okay,
them. So basically now
temperature.
it's like moving the PVC, moving the clay pot, moving the wood bag.
I'm taking the Niskin bottle 5 liters.
And exactly.
We have to confirm if all of them are in the same biobanks.
Exactly.
Okay.
Let me just ask. Do you want all of Gus's micro traps in the same one? Yes.
Okay, thank you. Condiciones principalmente microbiológicas, que son las que se harían en estas trampas que ven acá que está tomando la mano del robot. Hello, this is Maria from University of Costa Rica from the Geological Department. I will be principally speaking in Spanish, but if you have any question in English, just let me know. Bueno, estas jarras se habían dejado como una prueba para ver si los pulpas elegían este material, y como ven, por el momento no hay, bueno, hay un organismo que sí está atado a esta vasija. Los pulpos parece que no eligieron esta vasija por esta vez. Yeah, it looks like a coral attached to the jar.
Our first That divider wants to come out.
Let me try to get, let me try to close it for this. That's good. That's good. Don't worry about it. That's good. It's gonna be a dangerous spot to get. It's like all up in.
Un saludo a mis colegas de la Escuela Centroamericana de Geología que están escuchando la transmisión y pendientes de esta transmisión y de los análisis que estamos haciendo.
Yeah. It's almost like it's leaking. I'm not sure. Yeah.
I'm not gonna be able to give you any blue. I don't even know where it's at. Alright. Back to same thing. Alright, next thing is
So So we can, probably the next thing is pick up the wood bag.
Put it over.
we still have it.
And then we'll
So
pick up the one we measured,
Mhm.
but then we need to measure the temperatures in the zone.
Yeah, okay.
Hello.
So we'll continue taking this bag,
That
put it
bag?
in a way, yeah.
Okay. You got that where I moved the bag.
Bueno, aquí vamos a, bueno, esta bolsa que ven acá con un cordón azul, con una cuerda azul, contiene madera. Entonces esta será tomada para ponerla un poco lejos de donde están los pulpos y posteriormente la recolectaremos en otro momento y continuaremos tomando medidas de flujo de calor. Les recuerdo que aquí las pulpas están asociadas a fuentes, emanaciones de baja temperatura hidrotermal que sale de las fracturas de las lavas principalmente. Estas temperaturas se han medido a lo largo de todo este monte submarino y tienen variaciones desde los 2 grados hasta los 12 grados. Así que estaremos midiendo también las temperaturas con respecto a cómo vayamos recolectando los experimentos que se dejaron acá.
What was that? Yeah, we're relocating this. So this is over by that one. It's pretty steep over there. Is it okay to go down in front of the W?
Yeah.
Yes.
Yes.
So just extract in front of the W. Still working that out.
Okay.
No, they want to pour it out, that's it.
So
Now you want to start
yeah.
picking these up?
Yeah, we will collect this one and put it in the bio box 1,
Oh, box 1?
1A. Yeah.
So
Please.
this first one with the green.
Yeah. so
Yes,
the-
exactly. This one.
So now we're picking up the microbe chocolate green. Chocolate is the last one. But green is gonna.
Muchas gracias a todos y todas por estar conectados a nuestro primer buceo desde el Falkor 2 de la expedición Octopus Odyssey. Estaremos por acá hasta más o menos el 15 de diciembre
You want us to take our time, so she lets go?
para poder visitar ciertos montes submarinos de este sector, ¿verdad? Del sector del Dorado. Estamos posicionados a 200 kilómetros fuera de costa de la península de Nicoya, y actualmente estamos a 3.000 metros de profundidad aproximada, 2.998 metros de profundidad.
Whenever we're taking something off the seafloor, we want to make sure we get a nice picture of it.
Okay.
With the lasers on and off.
Okay.
And then, when we're picking it up,
Okay.
put it away, just so we can see what it looked like on the seafloor.
Okay. So we can turn on the laser, please.
Make sure to take a frame grab.
Like if we
Yes.
have to close it.
Yep, that's right.
Okay. Perfect.
Okay. I'm going to bring the portrait up a little bit. Open Falkor screen.
Bueno, un saludo a Carlos Hiller, que está saludándonos. Carlos participó con nosotros como artista a bordo de la expedición en junio, así que un abrazo, aquí lo extrañamos muchísimo.
So, anything, 1A.
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 Yeah. Bueno, este es uno de los experimentos que se llevan a cabo en la Universidad de California State, a cargo del doctor Gustavo Ramírez. Acá en este experimento se dejó en junio unos materiales, distintos materiales en estos tubos de PVC, y ver el contenido microbiológico, el microbioma que contiene en estos distintos materiales. Se seguirá el análisis en California, en Los Ángeles, disculpen.
So, going for that one over there, you're going with it?
So, yes. But we have to measure the temperature.
We measured the temperature of that one. It's the one down there that we did not.
Ah, okay, perfect. So,
Yep. So this is not surprisingly blue. That's you can
aquí vendría otro de los experimentos también que vamos a colectar, y viene otro material. Son unos 6 experimentos que se dejaron, 6 muestras con distintos tipos de materiales. No recuerdo los materiales, pero dentro de ellos habían algunas rocas, sedimento. Y algunos también creo que eran algún compuestos orgánicos. Same box.
Same everything.
Can we take a
Oh, yeah, go ahead.
Yeah.
What would you got?
for the picture, please, and the lasers on?
Lasers on for this one?
Yeah, please.
Sorry.
I see one of the lasers.
Yeah.
Just on both of ends. There you go.
Yeah.
Perfect.
Yeah, thank you.
Take a frame back.
A veces se ven unas lucecitas, en este momento se están viendo en el borde amarillo, y estos miden 10 centímetros, entonces los tomamos como referencia para conocer el tamaño y para poder entonces conocer la escala de la foto también. Generalmente se toman fotos, se graba video, así como lo estamos haciendo en este momento, para posteriormente hacer más detalle, anotaciones en los videos que se graban.
don't think so. No, we'll do the other things here in a moment.
Thank you for the close-ups. What am I looking at?
Okay, we are going to take the temperature close to the.
Move around and go get to the other one?
Yes, please. I think there are six samples or five. Okay.
It's fine.
Es un vidrio. Okay. Bueno, para comentarles los experimentos de Gustavo Ramírez, aquí tengo el dato. Tenemos en 5 muestras donde se dejaron distintos materiales. Uno de ellos tiene un basalto fresco y reciente, uno tiene un basalto de 23 millones de años, otro tiene rodocrosita, que es de carbonato de manganeso. También tenemos un material inerte que sería vidrio, y tenemos en otro acero oxidable. Así que estos serán los experimentos que van a ser conducidos y analizados por el doctor Gustavo Ramírez en la Universidad de Cal State en Los Ángeles. Aquí cuando vamos a tomar la muestra, antes de tomarla se intenta tomar un dato de temperatura, y tomaremos también lo que es agua en unas botellas Niskin, agua de mar. Un saludo a todos los costarricenses que están conectados y conectadas. Es un placer estar transmitiendo desde nuestro país en esta expedición y particularmente en este sitio tan impresionante para nosotros, y que nos llena de gran orgullo estar acá estudiando estos organismos que, como les comento, solo son 3 a 4 sitios en el mundo que tienen esta particularidad y que han sido estudiados, así que es un privilegio que en nuestro país tengamos este tipo de estudios, ¿verdad?, de organismos internacionales. Les comento que esta expedición somos 10 ticos y ticas a bordo. Venimos desde la Universidad de Costa Rica, Universidad Nacional, y también están algunos otros colaboradores y becarios, así que es una expedición bastante particular, ya que tenemos mucha participación. Principalmente tenemos personas expertas en biología, de diferentes áreas de la biología, y estamos 2 geólogos, el doctor Marino Proti y mi persona. El resto de la expedición está integrada principalmente por personas de diferentes universidades e institutos de Estados Unidos. Can we go
these two right here. In front
Do you
of us.
think that we can measure here around?
We have another now. And we want to focus on doing experiments. So measuring the experiments,
experiment.
getting them put away. Right, we're still up here. Oh, sorry, we're here.
Yeah.
So we still want to do these things.
Okay.
Now you're ready. Now get the camera over to you. You ready?
Un saludo a mis amigos y colegas geólogos y geólogas que están conectados. Ahí está Laura, Steph, enviando saludos.
So you got one right here.
Bueno, acá con este aparato vamos a medir la temperatura de cerca del otro experimento que tenemos.
Can we get the temperature overlay on?
Oops. Estos láseres se ven bien acá, estos puntitos verdes. Y miden 10 centímetros. Ahí está. Ahí estamos midiendo la temperatura. Si lo ven en pantalla, estamos a 2.78 grados centígrados. El Dorado, este monte submarino, se supone que tiene una edad de 23 millones de años. Estas lavas provienen desde la dorsal pacífica. Se generaron en esta dorsal y han viajado a la velocidad de la placa hasta la ubicación de hoy, hace 23 millones de años. Consisten principalmente de lavas volcánicas producidas, como les digo, en la dorsal y principalmente compuestas de basaltos. Para los personas que están ahí que saben un poco de geología. Bueno, estos flujos de calor se producen principalmente porque en algunos montes, cercanos como el Tengoset, se entra el agua fría en las fracturas de las lavas. Hace un viaje a través de la corteza tomando calor y encuentra su salida en estos montes pequeños como el Dorado.
So that's a good temperature measurement. So
Okay,
now we can
okay.
go to the next one.
Okay, thank you.
So you want to tell them to do the red one or the orange one?
I think the orange one.
Okay.
Yeah. Okay, we go to
That right there?
yes, please. Bueno, aquí medimos ya la temperatura y vamos a pasar hacia el otro hasta el otro experimento. Ya colectamos 2. Un saludo para mi hijo y mi mamá que están conectados. Les mando un abrazo. Los amo mucho. Me hacen falta.
Second lower.
Choose mine. I think this one's pretty cold.
All right, 2.2?
Yep.
2.20.
Or would you like us to go next with it?
Yes. To the red one.
Okay, let's see.
Okay.
You see that red one outside?
This is gonna be the winner chicken dinner.
See it out there?
It's in orange. A baby, a baby,
Ah,
a baby,
yes.
a baby.
Bueno, aquí estamos viendo un bebé. Es el primero que vemos.
Wow.
Así que siempre nos llama muchísimo emoción. Es la primera vez que, hace 10 años, en el 2013, se había visitado este sitio por primera vez en el 2013 y no se habían visto bebés. Se había venido en diciembre, no se habían visto los bebés pulpos. Se visitaron en junio en esta expedición y vimos los primeros bebés pulpos nacer o salir de sus huevitos, y acá estamos viendo el primero, así que nos llena muchísimo de emoción en ver este bebé pulpo.
No, it's like right down here. Among the moms. I don't know exactly where. Luckily, we have it all on video, so we can watch it twice. I can see it again right here. There's a lot of interaction going on.
Yeah, those.
I'm gonna bring the torch over there. I have to bring that way and then
If you can't reach, it's okay. We can get it when we're moving to the next operation.
okay. You see how far away he is? Oh,
Maybe
yeah, you're quite a ways away.
close by here.
Okay. Yeah, you wanna use-
Still on for sorry.
yeah.
Can we collect the 2 others?
Yes, we're gonna collect those and then we'll move in to get the
Yeah, work out a little bit
OsmoSamplers and
more.
then final one.
Okay. So and the rock sample, you want to take it away?
You should just be able to rest it on there.
That's a question we should ask us.
Okay.
once we get the experiments on, then we'll ask him when he gets that.
Perfect. Un saludo a Gwendolyn, que está acá conectada. También Wendy estuvo en la expedición pasada, así que aquí la extrañamos. Un gran abrazo. Es bióloga, estuvo trabajando con los corales negros en la expedición de junio. Así que un saludazo, Gwen. No la había visto conectada. Gracias, Emil, por el pulpito de Megagraft. Okay.
No, we're going to be using it again soon. All right, so we can start.
So he's gonna, yes, please. I'm going to the same books.
Yeah, I'm just going to pull the portion and get an image of it.
Okay.
Let me get an image real quick. Let me turn the lasers up.
Para comentarles un poco lo que estamos trabajando acá desde tanto del punto de vista geológico. Entonces tomamos muestras geológicas de sedimento, muestras de roca. Algunas muestras de roca se estudian con distintos propósitos. Se estudian las rocas desde un punto de vista geológico, pero también estas rocas se estudian su asociación con los microbios que están, o todo lo que es el microbioma que está en estas rocas. Así que tienen distintos objetivos. Además, los sedimentos también se les hacen análisis tanto geológicos como microbiológicos. Se toman muestras de agua para experimentos de acidez del agua, que estos se llevan a cabo en la Universidad de Costa Rica, principalmente, bueno, por la doctora Celeste Sánchez, que después les estará explicando un poco más de esto. Además, bueno, en general se recolectan organismos vivos, ¿verdad? Para la biología, y estos quedan en la colección del Museo de Zoología. Acá hay acá van a estar escuchando a distintos biólogas principalmente, porque ya que la mayoría somos mujeres, y explicándoles un poco acerca de esto. Además también algunos experimentos o mediciones de estas, principalmente de temperatura, que se han llevado a cabo en este sitio tan especial. Se estudia lo que es el flujo de calor en esta zona del Dorado, a cargo de especialistas de Estados Unidos como el doctor Andrew Fisher y Geoffrey Witt. Además tenemos otras personas que trabajan con lo que es la parte genética de los organismos, que también tenemos algunos investigadores en Estados Unidos que analizan el ADN de estos organismos, de estas muestras colectadas biológicas, y también en el Museo de Zoología de algunos otros organismos, como por ejemplo los octocorales o los corales negros. Aquí estamos colectando una de las muestras de los materiales que les comenté que lleva a cabo el doctor Gustavo Ramírez. Este material es interesante, se ve bastante como un color bastante distinto. Va a preguntar cuál será esa. ¿Esta es la rodocrosita? La rocrosita.
Orange is mild steel.
Ah,
Oh, it's orange. Okay. And it's foggy red.
but it's normal that
Mild
color
steel.
or it's just oxidized?
It's oxidized.
Oh, cool. Ok, esto es el acero y vemos que está bastante oxidado, así que este es un resultado preliminar. Ah, we have to take a picture. Right?
We take it.
Yeah, it's okay. Okay, thank you.
We got your back.
Thanks, Shaker.
Thank you. Bueno, un saludo a mi hermana que está conectada, un abrazote. Saludos a mi sobrina.
So make one more adjustment to get this place for getting that one. And then Gus,
That'll be all right.
what kind of rock in the middle of
Closest possible to the section.
So,
What are we doing next?
yeah.
There's one more out there.
Yeah, we have to collect the other one.
Right now, or is there something else we want to do?
No, I think we can collect right now.
Let's
Okay, so I gotta-
let's get that last one. And then
Let's see if I can. Yeah, that's what I was thinking.
potentially, I mean, your experiments are kind of all in that one area,
Yeah.
but like some are warmer than others.
Right.
So, just one rock.
Yeah.
Just
Truly representative.
just do this.
We'll expand the lead survey, I guess.
I'll stop right there. You guys do temperature? Did we get? We didn't get temperature on this one.
No.
We need to get temperature.
Yeah.
You want to get temperature on this one, or is
Yes,
your
please.
temperature sitting right here?
Our control.
So I don't know if you need to reposition to get
I just pulled the ROV in a lot. Let me
Okay.
push out for you.
Les comento que en el sitio, este es el sitio icónico, ¿verdad? El que se descubrió de primero por unas observaciones hace 10 años. Se vio esta agrupación de pulpas anidando cuando se estaba estudiando con otros fines, unos fines principalmente de estudios de flujos de calor en este sitio, estudiando el acuífero que hay acá, el acuífero pues en el mar, en la corteza, perdón, acuíferos marinos pues. Entonces, desde esa observación que se realizó, estaban tomando estas tomas de flujo de calor y demás hace 10 años, y fue cuando vieron estas agrupaciones de pulpos. Esto se ha observado también en otros sitios, pero sigue siendo algo bastante único, así que es un sitio muy especial, ya que hay estas emanaciones de flujo de calor de baja temperatura que le llamamos, y es la misma agua, un agua un poquito caliente que se asocia, digamos, con estas agrupaciones de pulpas. Posiblemente parte de las hipótesis es que esto puede ser que ayuda al crecimiento de los huevos. También puede ser que el agua, al mantener la roca tan limpia, pues es favorable también, o múltiples hipótesis, ¿verdad?, que pueden estar asociadas a esto. Esto que ven como un agua un poquito turbia o en movimiento, es esa agua un poquito
maybe yeah, towards the yellow.
24, 27, no, 29 there. Aquí estamos midiendo la temperatura antes de recolectar el último experimento que tenemos. It's good, yeah.
Seems like it would be warmer.
Yeah.
It's a little bit warmer. Not 2.7.
I think the venting is in front of us and it's behind the venting.
Yeah.
Sí, entonces esta agua, como les comento, que se ve un poquito como moviéndose, es esta salida de estos flujos más calientes.
Yes. 3.2.
Acá la temperatura la tenemos a 3:37 en ese momento.
Temperatures for this area? Or for this little section? Go ahead
For the moment, yeah.
go ahead and recover that guy.
Yes.
No, en este momento las pulpas, ellas tienen esta posición para proteger sus huevos,
Hold tight for 1 second.
y en este momento simplemente están tranquilas y no es que están sufriendo o tienen ningún tipo de afectación con respecto a los experimentos que se han dejado. Los experimentos nada más se ponen a la par porque es para estudiar las comunidades de microbacterias que están ligadas a estas rocas y a este ecosistema.
Just touching the rock like that? Or?
Perfect.
Okay.
Yeah, just trying to get an idea of how warm it is.
Like that.
Also,
So 3.81.
Aquí, como les comentaba, se está midiendo la temperatura. Estamos a 3.22. Está aumentando un poquito. Las variaciones en este sector varía de 2 grados aproximadamente hasta 12 grados. Y este sector es del monte submarino, que está prácticamente en la cima de este monte submarino, el Dorado. Es donde tiene la mayor agrupación de pulpas que se han visto en el sitio. Y así como es un sitio, uno de los sitios únicos en el mundo que tienen este ecosistema tan particular, también así es como gracias a estas expediciones y a los estudios que se realizan, es que podemos llevar a la protección de estas áreas y a la futura conservación.
Photo, not just like keep messing with my laser, but
that's great.
Okay, I got one.
sweet. All right, let's go grab it.
Yes.
This one's also going in bio box 1A.
Yes. Para comentarles que olvidé al principio decirles, acá las personas que manejan lo que es el robot son pilotos expertos que manejan el robot Sebastian, que así es el nombre del robot que tiene el Schmidt Ocean, el barco, el Falkor 2, y ellos manejan todo lo que son estos aparatos o estos como por ejemplo esta mano de robot y demás.
There's still so much octopus activity going on over here in the corner.
It's the same photo.
Yeah. It's really impressive.
Tenemos que colectar una muestra de roca. Sí. Y tenemos que medir tomar una medida en esquina de 5 litros. Ok. Entonces voy a anotarlo.
Oh, okay.
Bueno, aquí recolectamos entonces ya lo que son las 5 muestras para el experimento, para los experimentos que van para la universidad para Cal State en Los Ángeles, y seguiremos tomando algunas muestras de roca y de muestras de agua. Por el momento yo los dejo. Fue un gusto estar acá con ustedes por primera vez después de 5 meses desde la última expedición, así que nos vemos mañana. Estén conectados y conectados de este sitio tan particular. Mañana estaremos en otro sitio también así de particular que le llamamos la pulpería, y los dejo a cargo de Beatriz Naranjo de la Universidad de Costa Rica y de la Asociación Pélagos. Muchísimas gracias. Que pasen buena tarde.
How are you? Good. All right, you want a rock now, huh? You want this rock?
Yeah, we want the rock by the box. The B part.
B2?
Yeah, just to the right, the BB one.
Okay. Let me know when y'all got the image.
Got it.
Hola, muy buenas tardes. Es un placer saludarles desde el Fondo Oceánico de Costa Rica. Para nosotros es un privilegio poder estar acá. Mi nombre es Beatriz Naranjo, formo parte del equipo de investigación de la Universidad de Costa Rica y también formo parte de un colectivo de arte y conservación por el océano llamado Pélagos. Tengo el honor de estar con pilotos muy diestros en el robot que estamos utilizando, conocido como Sebastian. Me acompaña J-Rod, Claude, y en el micrófono y en el apoyo multimedia me acompaña John. Como parte del equipo científico tengo el honor de estar al lado de Leonardo Chacón, que también es parte de la Universidad de Costa Rica. Para nosotros de verdad es un honor, nos sentimos muy privilegiados de poder tener la oportunidad de estar aquí y que el Falkor 2 y Sebastian estén explorando nuestro mar profundo. Good afternoon, my name is Beatriz Naranjo. I'm from the University of Costa Rica. It's a pleasure to be here today as part of the Costa Rican team on board of Falkor 2. We are exploring an area known as Dorado Outcrop, close to 200 kilometers in front of the coast of the Nicoya Peninsula in Costa Rica. We visit this place in June and we are happy to be back seeing all these females giving this show, taking care of their eggs. Como parte de los experimentos que estamos desarrollando aquí en el Dorado Outcrop, como pudieron ver y como María les explicó, estuvimos recolectando unos experimentos para microbios, unas trampas de microbios con diferentes sustratos, como parte del trabajo de colegas de Caltech en Estados Unidos. Y ahorita estamos recolectando una roca con esos mismos propósitos de estudiar la relación de estos fluidos hidrotermales ligeramente más calientes que el agua alrededor y ver cómo se componen, cómo se diferencian de otros sitios y cómo pueden estar pues influenciando la presencia de estos pulpos que estamos observando.
Do a glamour shot of this, please, before we put it in the file box. Oh, okay.
What's that?
Is it past? Yeah, there we go. We got the lasers on it. So now you see the lasers are on the rock. So you like frame grab.
Para quienes nos pudieron acompañar en la expedición de junio, estamos en los mismos sitios de investigación que visitamos y en esa oportunidad dejamos una serie de experimentos que son los que estamos recolectando ahora. Nos faltan varios experimentos por recoger. Hay mucha tecnología, tanto a bordo como en el robot submarino, que nos permite entender mejor estos ambientes tan desconocidos.
And then?
Then we need to fire 2 whiskey bottles of 5 liters. And after that we need to pick up flows and put them for the OsmoSampler on the temper and leave them in the tray. And just to
Okay, so then you want to
blur
do the same here.
for the video.
We're going from this to that?
Experiment? Oh, sorry, no, it's R.
But maybe wait a moment until they are ready.
And then with the description, see what I wrote there.
Probably 1 and 2, but
Now we want to take this case. Yeah, you ready? We're almost ready. That's all your way.
En junio pasado hicimos algunos descubrimientos bastante importantes relacionados a esta guardería de pulpos. Han sido 5 meses entre expediciones, no ha sido mucho tiempo para poder procesar toda la información que recolectamos la vez anterior, pero como resultados preliminares hemos obtenido datos bastante interesantes sobre la biodiversidad de todos estos ambientes. Y todos estos datos que estamos recolectando nos ayudarán a tener un set o un complejo de datos más fuerte para poder arrojar conclusiones sobre estos sitios. Este sitio que estamos observando es realmente único hasta el momento, o bueno, hay muy pocos sitios en el mundo donde pasan estos fenómenos, donde podemos observar tantos pulpos cuidando a sus crías.
what's up? How you doing?
Good. I'm good. You?
That's where we're sitting. It has a big marker.
You didn't get to fly last time on Dorado,
Probably
yeah?
saw it.
You were able to fly over Dorado last time?
Can't remember. I don't think so.
I don't Uno de los aspectos que más rescato de toda la oportunidad que implica estar aquí es que ha sido una oportunidad sumamente valiosa y única para... Ha sido una oportunidad única para formar nuevas personas en el campo del océano profundo. Muchas de las personas que estamos aquí a bordo aún estamos empezando o en estadios tempranos de nuestras carreras, y estar aquí nos llena de muchísima motivación para seguir adelante. Ha sido una oportunidad única también para fortalecer el grupo de costarricenses. En estos 5 meses hemos estado trabajando muy de cerca, reuniéndonos, conociéndonos mejor entre nosotros y formando un equipo interdisciplinario que nos haga capaces de realizar nuestra propia investigación en nuestro mar profundo. Acabamos de recolectar 2 muestras de agua. Esta agua también nos ayudará a entender mejor las propiedades físico-químicas de este sitio. Para aquellos que acaban de sintonizar la transmisión, estamos explorando un sitio conocido como Dorado Outcrop frente a la costa de la península de Nicoya, en frente de Guanacaste, en Costa Rica. Nos encontramos a casi 3.000 metros de profundidad explorando uno de los únicos 4 sitios conocidos en el mundo donde podemos observar este espectáculo de pulpos. Now we have to pick up the floats. First the A1 to take them out of the way and leave it on the tray. We will collect that at the end of the dive.
At the end of the dive?
At the end of the dive.
Photos needed or anything of this?
It would be good to just get some close-ups of the temperature logger and OsmoSampler intakes. Maybe a short video highlight.
Like this?
Perfect.
Como pueden ver en este acercamiento, vemos agua más caliente mezclándose con el agua más fría de los alrededores, que es agua que se está filtrando por las grietas de estas lavas. Y esa es principalmente la principal razón por la que vemos estos pulpos aquí. Así que ese sistema de agua con el fondo oceánico es el que estamos intentando estudiar desde diferentes perspectivas para entender mejor la biología de estos pulpos.
Temperature logger is going in the basket?
It's going to go into that milk crate in your sit cam.
Okay. This is all one thing?
It's 2 separate things with those 2 separate floats.
Okay.
So you're picking up the temperature logger first. We're going to put it in the milk crate, and then we'll get the intake for the OsmoSampler and put it in the milk crate.
Este equipo que estamos recolectando, que ven en pantalla, es un sensor de temperatura que dejamos en junio anterior, y los datos que tenga van a ser muy importantes para entender las variaciones de este flujo y su temperatura en un mediano plazo. La caja que ven, donde estamos colocando el sensor de temperatura, es un equipo conocido como OsmoSampler. se utiliza para filtrar agua a velocidades muy lentas. Entonces lo que ven aquí son aproximadamente 300 metros de un tubo plástico muy delgado, donde el agua se filtra lentamente sin ningún mecanismo de energía alterna. El agua se filtra por ósmosis, es decir, se pone una sal o un componente que permita tener una solución más saturada que otra para incitar el paso de agua de la superficie, perdón, de los alrededores. Entonces básicamente lo que tenemos aquí es un reloj de agua donde podemos obtener el agua en pequeños segmentos del tubo y saber hace cuánto esa agua se recolectó en el OsmoSampler, y así tener una serie de tiempo con las propiedades físico-químicas del agua que se ha estado filtrando. Por ahora estamos poniendo al lado estos experimentos para recolectarlos al final de nuestro buceo. Esperamos estar aquí en el fondo aproximadamente hasta las 10 de la noche, así que esperamos que nos acompañen. Vamos a estar en esta zona de estudio hasta aproximadamente el 13 de diciembre. Recuerden que tenemos que la transmisión en vivo en YouTube y Facebook es posible dejar sus comentarios, así que si tienen cualquier pregunta en inglés o en español, les invitamos a hacerla. Tenemos varias personas aquí en la sala de control con diferentes disciplinas. A bordo tenemos personas de microbiología, biología, geología, geofísica, una serie de profesiones que hemos acoplado para entender mejor este lugar. Okay. Un saludo hasta Argentina. Muchas gracias por seguir la transmisión desde todo el continente.
Do you want us to tuck all the hoses in right now?
No, we'll do that when we're going to actually put it on the basket.
Okay. Go ahead and stow the arm, or are we moving something else?
We're ready, right?
We're ready to do the temperature and dissolved oxygen.
Yeah, we need to do the different temperature and dissolved oxygen measurements. You want it here in the same side, like
So where we just pulled that stuff out of is probably the most flow.
Okay.
So that's where we want to focus.
Okay.
I would, I think stow that on. You want to do oxygen?
Oxygen and temperature, yeah.
Both?
Both, yeah.
Alright, so we ready to grab both from watch out for it.
Este es el sensor de temperatura. Vamos a estar tomando diferentes mediciones de temperatura y oxígeno disuelto. Justo donde tenemos la salida de agua más caliente. En este sitio encontramos variaciones entre 2 y 12. Yeah. There's a lot there. Might be a good spot.
It looks like it's coming out with that shrimp race.
Alright, so let me try to get you in a little bit closer.
If there's a spot that looks better, that's reachable, we can also probe that one first. Whichever, we don't have to go to the one that's the most vigorous to start with. So what we're trying to do is just poke around and everywhere that looks like there's venting.
As many as we can.
To see which has the warmest fluids with the lowest oxygen.
Ahorita vamos a hacer estas mediciones de temperatura y oxígeno para ver en qué punto encontramos el agua más caliente y el oxígeno más bajo y comparar qué tan variables son estas salidas de fluido hidrotermal. Esta agua se está filtrando por principalmente lavas. Todas estas rocas que vemos son lavas principalmente. Como ven, hay organismos muy específicos asociados a estas salidas de fluido hidrotermal. Vemos gusanos blancos adheridos a la roca. También vemos estos camarones que son bastante comunes y que son uno de los principales depredadores por los cuales los pulpos hembra tienen que cuidar a sus huevos. Most of the rocks we are seeing are lavas. This place was formed in the Eastern Pacific rise, so it's basically volcanic activity, and then they migrated where they are today because of the tectonic. Mm-hmm. 10.4, 10.5, 10.8.
Is it working though, Joe?
It is working.
Okay, so go ahead and grab it, pull it up.
Yeah, you're good to use it.
All right.
It'll just be, we'll get on the screen.
Is there some more juice?
Is there anything other than this that could make work?
Vamos a trabajar con otro sensor.
So I think we can go ahead and call this one an 11.4.
You want to do both at the same time?
You want to see that? Oh, I didn't even notice that he had it up. I couldn't see it in this camera. Sure, yeah. If you want to hold that arm and bring the dissolved oxygen in, why not? So they're keeping the temperature where it is. Now they're bringing in the dissolved oxygen. So for instance,
Este otro sensor que estamos colocando es para medir oxígeno disuelto. en pantalla alcanzamos una temperatura máxima de 11.9 grados Celsius. Y ven en pantalla en la esquina inferior izquierda la temperatura del agua circundante, que es el sensor que está sobre el ROV Sebastian, no sobre el sensor específico. Y como ven hay una diferencia de casi 10 grados.
Are the readings good or bad?
Give me 1 second.
Okay.
So I'm trying to compare it with what Grafana is reading on the CT. So Grafana has 118 as the micromolar, so maybe that first column is right.
Yeah. Ours is also compensated.
Yeah.
So that will be a difference. I can give you an unchanged value.
This you don't need the absolute.
That's what they're working on back there. I can only show you where ours is.
Alright.
The numbers are updating. Okay, so I need to scroll down. Okay, so it's going down. Okay, keep holding where you are. Doing good. We've definitely got a lower reading.
Alright.
And now, so hold on that. Delete that number. The 118. So now what we're looking at are these numbers coming in. So
En el plan de buceo de hoy, más adelante tenemos la prueba de algunos equipos que no vamos a estar utilizando como tal el día de hoy, pero que queremos probar para los futuros buceos, asegurarnos de que todo esté bien. Como les comentaba, es un equipo interdisciplinario, tenemos también personas de ingeniería a bordo, así que es una combinación bastante interesante y una oportunidad para todas las personas que estamos a bordo de aprender sobre otras áreas y de potencialmente combinar nuestras investigaciones.
background is 118.
Okay, cool.
79. Okay. Yeah, I just wanted to make sure that it was working first.
Okay, cool. All right, good.
Okay.
Shred.
J-Rod,
Yes, ma'am.
do you think it's possible to push it down any further?
Yeah, we'd have to get the probe out.
It's okay to like push it down by the shrimp or.
You're good to come out a little bit. Is that clear? You're good to go. So, like, you want to get into that flow, right?
Yeah.
That seems like, I mean, it just seems to be further back. You can go and pull yours out. I don't know. Yeah. They want this one going deeper.
Okay, so 11.9.
Mhm.
Up 12.
12.
Good.
Yep, just come to the right for a little bit. Yeah.
Cool. We look at real-time video.
Hold that.
Este es el primer buceo de nuestra expedición. Zarpamos de Ciudad de Panamá hacia Costa Rica en un tránsito de unas 70 horas,
Let's see, I'm trying to be
durante el cual, además de terminar todos los preparativos que teníamos que hacer, también tuvimos algunas charlas a bordo por parte del equipo científico, unas charlas abiertas a toda la tripulación también y una oportunidad de compartir con la tripulación que tiene muchísimo conocimiento de todos los mares profundos literalmente del mundo. Personas que no tienen formación científica, pero no la necesitan.
Oh, yeah, that looks great.
Increíble el conocimiento de todas las pilotos a bordo y el equipo de técnicos marinos.
So I think there's a delay. So because it was going down while it was looking away, that makes more sense.
Yeah, it takes a while for it to go up that tube, I believe.
Yeah.
You want the temperature probe to come back in, or?
I don't have an answer
Yeah, totally bugs it.
Okay, now the DO is dropping again. Yep.
Estamos intentando obtener una medición del sensor de oxígeno disuelto lo más cerca de la roca posible.
Got some egg. You got some eggs at the top of the screen. So you know.
Yeah.
It's okay to
For,
move the camera around while we're doing this, because we're just gonna hold
Well,
it here for a
I
minute.
can't freeze this one.
Okay,
If I freeze this one, our arm jumps up.
got it, and we'll wait.
We're seeing on the screen a lot of octopus, female octopus, brooding their eggs. Some minutes ago, we saw one baby octopus.
Concentration still dropping. When we did this 10 years ago, we had an autonomous lever, and that's the temperature, that's the concentration we projected. This is the first time we're measuring things.
They're a little bit deeper. They got a little deeper.
Como parte de nuestras actividades de comunicación, conforme desarrollamos la expedición, estamos organizando y en este momento se está llevando a cabo una en vivo, una transmisión conocida como Ship to Shore, que es una iniciativa de Schmidt Ocean por traer a las personas virtualmente a explorar un poco más el barco, principalmente los laboratorios, la sala de control y todo el equipo científico a bordo. En este momento estamos desarrollando una con un grupo de estudiantes de la Universidad de Costa Rica.
I think we're good.
Más adelante en la semana tenemos planeadas varias conexiones con diferentes colegios, universidades, comunidades.
Push it in any further, that's great. If that, I don't know how deep your hand is happy with holding that. Okay.
Different angle, maybe deeper.
I mean, this data looks great, so let's just see if it changes. It takes about a minute.
I'm gonna try to exit out and see if it'll hold.
Los láseres que ven en pantalla de color verde están separados entre sí por 10 centímetros. Para que se hagan una idea de la escala de estos pulpos, son en realidad más pequeños de lo que al menos yo pensaba. En los últimos meses, el ROV Sebastian ha estado explorando no solo las aguas de Costa Rica, sino también áreas de Galápagos y también dentro de la zona económica exclusiva de Costa Rica, cerca del Parque Nacional Isla del Coco, que es uno de los lugares que mejor entendemos en cuanto a aguas profundas. Y toda esta información recolectada en los últimos años han cambiado por completo nuestra percepción sobre el mar profundo. Sin embargo, sigue siendo una Costa Rica bastante desconocida y parte de lo que estamos intentando es pues montar una línea base para seguir investigando estos ambientes y, por supuesto, haciendo lo posible por conservarlos.
Yeah, we're doing another measurement right now. This one is ready or not? Right, and we're just discussing this. Slowly pressure corrected. Anyway, so I think the lowest one we just measured was 56.1. Yeah. We didn't get a temperature measure for this one.
Do you want one? That's right there.
No, it's fine. We're good. You can go ahead and pull the dissolved oxygen for that.
That sensor doesn't read temperature?
It's also recording temperature on the
Okay.
bottom.
Gotcha. Cool.
So technically this is also temperature.
All right, so good to move it out of there?
It is 11.5, 11.6. I'm assuming that would column is temperature.
Yeah, that's your story.
Second column is.
Yeah.
Right, I just want the dissolved oxygen.
Yeah, 100%. Just letting you know that's so.
Gotcha.
You put it in the point spot. I don't want you to appreciate that.
Jared?
And so like an extra canvas now?
Yes, thank you
And
so
then
much.
I'll try to put it on an actual screen.
I appreciate that.
Shoulders real laggy on this. Yeah. All right, can distill
Okay.
this?
Yes, please.
So-
You can still both of them.
All right.
I think that's the best spot. That's why we put that stuff there. So it's really just confirming that just sent Julie a message that the moved to super. Alright.
That's how I took it out.
Nice.
Ahorita en unos minutos vamos a tener a la doctora Julie Hoover, es parte del equipo de Estados Unidos que nos acompaña a bordo. Ella trabaja con microbios y junto con una ingeniera, Amanda, estuvieron trabajando arduamente los últimos días con el ROV Sebastian y su equipo para dejar a bordo, para acoplar al robot un equipo de filtración de agua que van a estar estudiando para conocer mejor si en estos flujos hidrotermales hay una cantidad o diversidad diferente de microbios comparados a los que están en el agua alrededor. Todos estos muestreos de agua comparado a las colectas de rocas y las trampas de microbios que hace unos pocos minutos estuvimos recolectando con sustratos dentro de las trampas nos permitirán entender mejor la biología de este lugar, la microbiología y cómo esto afecta a la biología. Así que por ahora estamos guardando los sensores y empezar a prepararnos para el muestreo.
Okay. So as long as you are done and ready to hand over the next thing by 7.
7 o'clock. Okay.
Maybe you can try this. So Bea is here.
Okay. So the hottest we got was 12, and
Jeff just got 56?
Yeah, and
Okay.
that's the spot where we consistently put the osmos and the stuff there.
Yeah,
So
okay.
That's still really high.
Okay. So that's the place to put the super intake.
Yeah.
So
You want to start just after this? We don't need to move, right? We don't need to move. We just say we're just gonna sit. If you want to sit, just let me know.
okay. I mean, it,
You don't have to get in the ring, but
Vamos a quedarnos
They're still stone and that stuff.
en este mismo sitio para hacer el muestreo que sigue a continuación. Este fue uno de los sitios más activos, con flujo hidrotermal más activo. Fue la razón por la que decidimos colocar acá todos los experimentos que veían en pantalla.
So,
Yep.
yeah, we can, once they're done,
Mhm.
we want to kind of get move back to the spot where we were just doing the measurement,
Mhm.
and you know, if there's any eggs nearby, we want to have looks at those. But let Julie get set up, and then we can spend the time looking at other stuff.
Okay. Great.
And
Alright, so now we need to get the super. So, put down, where's our handle? Yellow handle. I think you want to use starter or this?
Otro de los objetivos que tenemos en esta expedición es nombrar todas estas estructuras o lugares que hemos estado visitando. Algunos ya han sido visitados antes, entonces tienen nombres en la literatura. Otros fueron visitados por primera vez la expedición pasada, así que los estábamos llamando sitio desconocido al suroeste de algún otro conocido. Y como objetivo tenemos principalmente el equipo costarricense hacer los trámites necesarios para someter nombres oficiales y que puedan aparecer como tal en los mapas. Muchos de los lugares tienen historias divertidas. Tenemos a bordo un investigador que estuvo en una de las primeras expediciones a este sitio y él utilizó parte de su español de secundaria del colegio para nombrarlos. Así que muy interesante ver nombres en español, sobre todo si tienen nombres interesantes, ya que muchas veces los nombres que vemos en los mapas no tienen la lengua oficial del país. Y como comentamos desde la expedición anterior, eso ha sido una de las principales hazañas, diría yo, de esta expedición, de mezclar un equipo local y diverso en la investigación del mar profundo. Así que un saludo a todos y todas las colegas de la Universidad de Costa Rica, la Universidad Nacional y de diferentes instituciones costarricenses que han seguido la expedición. Hoy en el descenso vimos animales sumamente increíbles en la columna de agua. Vimos una medusa gigante de 3 metros, una especie con pocos avistamientos, menos de 100 históricamente. Vimos algunas otras criaturas con colores realmente sorprendentes y simplemente lo que dijimos es que estar de vuelta y estar acá con todas estas pantallas viendo toda la diversidad.
oh, can we get power to the instrument? Okay, so the super.
Can we power the super?
Super's on.
Thank you.
You don't have
Ahorita vamos a empezar a preparar esto que ven en pantalla. Es un equipo conocido como el SUPR. Es básicamente sirve para filtrar agua con sensores.
Do everything we want here, then for the very end. Okay.
You don't want to do that when you're from outside. So you have that nice. Yeah, so now you can easily.
Yep.
Bring that around like that. And you're going to get that nozzle coming out. There you go, just like that. Alright, and then we're going in that same hole. See that shrimp right there behind the camera, just to the left of the camera.
Perdón.
That hole. This is the way they just better use. So you don't want to come too straight up in there, but because you got to get right by the, there you go, just like that.
Okay, so everything's being controlled by ROVs?
Is there something you need?
Nope, I'm just trying to understand.
You want to see here? You can see here.
You still got a ways
Not
to go?
yet. Okay.
I got eyes on everything, you good? Yeah, see what I mean, see what I did when they freeze it while I was in there?
Do that in all the orientations or just?
See, yeah, this one does, it's the shoulder edge up there.
Okay, so
If you hold there long enough and exit, it might be fine. So I got a view of your, and also here as well. It's just about to go out of sight, so, yeah, now it's out of sight, so like, yeah, like that, you got a view of it. Yep. So just to the right of that octopus.
We don't have our thumb printing yet,
Yeah, but,
so we won't be able to tell you if we're in it.
okay, but we're still good to keep working our way there, is that right?
Yes, yes.
Okay.
Yes.
Alright, now you're going too far. Yeah, so start going down.
Sorry, I don't know how to use this. Isn't the sample
Just
ID,
past the octopus, into the octopus neuron.
the sample number? Right.
Now go away.
Okay.
Down toward that shrimp. Kick them in there. That's what we're doing.
We are F, I believe, is the abbreviation for fluids.
Down.
Fluid, F.
Yep, just like that. Keep going in there. You can get a little bit lower, that's fantastic. Yeah, I might pull up, take out, hold that, and see if you can hold it together for a little bit, and then try the heads. And then we can test if it works. Well, they're still working on this stuff like that. Yeah, so it's always best to do like a, little bit nice and stable. You have to
Slow rate. Okay, and then that's it.
Cool. We'll hold that for right now, see what they say. If they want to readjust things.
Yes.
We're in a beginning position, so let us know if you want any description here.
So not until we start, but yeah, when we start, we're gonna, alright, let's wait on this. Great. Okay, I'm gonna have, I'm gonna talk for a minute. Okay. By a minute, I don't mean
Un saludo a todos y todas las colegas de Geología que han estado poniendo mensajes. Tenemos a bordo a María Sandoval y a Marino Proti. También tenemos geofísicos, colegas de Estados Unidos, incluyendo a Andy Fisher, una de las personas con más experiencia en estos sitios. Él ha estado visitando esta área de investigación desde el 2002, no necesariamente en un submarino, pero sí con equipo desde barco.
I would say it's about 3 and that's a good average. Okay. This one's half a liter per minute. Why don't you put in? So that's slow, right? That's slow. Okay. And you want to do fast. Let's just see how it compares. So it's like a liter and a half. 9.2. And what's happening with our temperature? So that's probably what we want to sample at.
Increíble.
That's the best. Yeah. Because remember, we need to just place the volume of our bottles 5 times.
Esta que estamos observando es una especie aún no descrita de pulpo.
So are you happy to
Tenemos a bordo a la doctora Janet Boyd, una especialista mundial en este grupo.
stop? I'm going to proceed to 14. Next.
Que ha estado trabajando muy de cerca con Fiorella Vázquez, una estudiante de la Universidad de Costa Rica, también especialista en este grupo de animales.
Then 10 minutes later or so, we'll say stopping.
Also, I want to say hi to all the scientific crew that participated on the first leg of the expedition and that they're not here. We miss you.
So C-log records when a sample starts, right? So it could all be in the details.
Okay, we're seeing like full fights.
And then we'll
Wow.
also tell you the max temperature we saw. But it's kind of, I don't know how you guys have been doing it. Like, do you start the sample when the sample is starting?
Not necessarily. So
Okay.
often we're using to describe what's going on, to get pictures, whatever.
Okay.
And then once we're actually putting it in the basket, then we put the sample ID and like where it went and all that stuff.
Oh, okay.
So what that's just when the sample's actually collected.
Yeah.
¿Qué tiene el plan de buceo? Vamos, ya
Yeah, so
completamos
how about
esto.
when we
Ahora
start
va a
it,
empezar el
you just
SUPR
write like
sampling,
starting
que es el equipo que ellas
supermodel
montaron en
number
el RUB
2,
para filtrar
and
agua.
then when we're done, we can make an official sample.
Y así que ella
and that's
termine.
when we'll tell you the temperature.
Sí, pero va a tardar un poco, están ahí como... Va a tardar un poco y después vamos a movernos, ¿ves? Que hay 2 horas aquí entre esto y esto. Así que creo que va a ser un poco lento. Puede hablar de la tectónica. No, simplemente si ellas ocupan algo, pues se les dé una explicación especial a los pilotos, le van a decir. Y aquí imprimimos como... Sí,
Because this is in
está el
chronologically,
chat
it's just on that
de
sheet.
Okay.
YouTube, Facebook
So 0, 1, 0.
y todas las pantallas.
And then, Hugh, start.
And are you going to
Ahí pueden ver los comentarios y también imprimimos esto como ideas. Tal vez un poco de explicación de qué hace cada quien.
I can
Sí,
also,
todavía esto no
I
sé,
can ask them
hay
to-
mucho.
Can you guys just zoom in on our intake real quick? Am I not allowed to stuff up here? I feel like I'm
Este experimento que estamos viendo en pantalla está siendo realizado por la doctora Julie Hoover de Woods Hole Oceanographic Institute
Yeah, we're getting between like 9 and 11, which
en
is
conjunto con Amanda Sutherland, también de la misma
I
institución.
think for this particular type of sample, since it's collected over a long period of time, that's what I would suggest. So when you're ready to say that you're starting, tell him or report to start.
Okay.
And then when you're done and you want to report any other information,
Okay.
then you can do the same thing.
Okay.
And
Okay.
that way the record, it still keeps the sample number.
Yep.
And just gives us the description.
Okay.
And then when they, if you don't mind, print it off.
Wait a minute.
Yeah, for this it's a
Okay.
because so I
So we're on port 2.
is that behind the camera is where all the samples are actually stored.
Para quienes se acaban de unir a la transmisión, estamos explorando el Dorado Outcrop, un sitio donde evidentemente lo caracterizan estos pulpos hembra cuidando sus huevos. También observamos algunos machos intentando copular con las hembras. Y la razón por la que están aquí está muy relacionada a flujos de agua que viajan por la corteza terrestre. A continuación, después de mi turno, voy a darle el paso a Marino Proti, así que van a escuchar probablemente datos muy interesantes de la geología y tectónica de este lugar.
We're sampling bottle 2 on the SUPR.
Este equipo ellos lo conocen como un SUPR. Es un equipo desarrollado para permitir filtrar bastante agua y tener mayores cantidades de microbios. O sea que al mismo del fondo va a venir agua ya filtrada, con la cual van a seguir realizando experimentos aquí en el laboratorio con un equipo bastante especializado.
Should see the GI go away. Yep. It should take about a minute and a half for it to go away. We're coming up on a minute and a half.
Un saludo hasta Colombia a nuestros colegas de la Universidad de Caldas.
Oh, you're right, we're in a minute now. It looks like it's low. No, it's still low there. We also have to displace all the tubing water.
For those who are seeing us, we are making shifts of 1 hour. Many of us are Spanish natives, so we are taking the opportunity to speak with our the people of our country in Spanish. So you will have some English spoken persons in some of the shifts.
Exactly what J-Rod's doing right now, getting different shots of images of the octopus. We're looking to see if there's evidence of eggs, babies, movement, things like that. We can also
Este pez que vemos en pantalla es uno de los más abundantes en este sitio. Es un sinafobranquio, posiblemente uno de los principales depredadores también de los huevos de estos pulpos, si las hembras no estuvieran cuidando a sus huevos. Como les comentaba, esta ha sido una gran oportunidad para todo el equipo de investigación costarricense. En esta expedición de diciembre tenemos el honor de tener en el equipo a Marino Proti, quien es parte del Observatorio Vulcanológico y Sismológico de Costa Rica, así que él nos estará acompañando en unos pocos minutos. Aquí podemos ver toda una diversidad de organismos asociados a estos ambientes, plumas de mar, esponjas, gusanos. Esta pluma de mar que estamos viendo en pantalla es un organismo emparentado con los corales. Es un tipo de octocoral, corales que tienen 8 tentáculos en sus pólipos. Esos son algunos gusanos, poliquetos. Todas estas imágenes nos van a permitir comparar con las imágenes de la expedición anterior y también imágenes del 2013, 2014, cuando el sitio fue visitado por el submarino Alvin. Nos va a permitir comparar la densidad de pulpos y saber si han cambiado en el tiempo. Aquí vemos algunos huevos. Parecen ser huevos en estadios tempranos de desarrollo. It was a pleasure to be with you. I will leave you with Marino Proti. He's a geologist from the Observatory from Costa Rica. It's a volcanologic and seismographic observatory of the country. So you will be hearing really nice stories about the geology of this place. Para mí fue un placer acompañarles en esta hora. Muy emocionada por estar acá, por ver qué animales y qué descubrimientos vamos a hacer en esta segunda parte de la expedición Octopus Odyssey. A continuación los voy a dejar con Marino Proti. Él es parte del Observatorio Vulcanológico y Sismológico de Costa Rica, así que muy interesante escuchar desde la parte de sismología y tectónica cómo estos lugares fueron formados y cómo todos esos procesos a nivel de tiempo geológico han influido en todo lo que estamos observando en pantalla. Así que los invitamos a seguir disfrutando de la expedición. Muchísimas gracias y nos vemos mañana.
Buenas tardes, mi nombre es Marino Proti, trabajo para el Observatorio Vulcanológico y Sismológico de Costa Rica, un instituto de investigación de la Universidad Nacional. Estamos siendo parte de una expedición multinacional y multidisciplinaria, estudiando comunidades de organismos que se han desarrollado en el fondo del mar, específicamente en un grupo de pequeños montes submarinos que se encuentran a unos 200 kilómetros al oeste de la península Nicoya, a profundidades de alrededor de 3.000 metros. En este complejo de montes submarinos se da un proceso bastante interesante y es la circulación de aguas del mismo océano que penetran por ciertos montes submarinos y afloran en otros montes. Esta agua, en su paso por la parte más superficial de la corteza oceánica, es calentada principalmente por el gradiente térmico, y en los lugares en donde sale con una diferencia de casi 10 grados con respecto a la temperatura del fondo del océano. En esta región, en esa zona que estamos viendo en estas imágenes del sumergible Sebastian, la temperatura del fondo del mar es de alrededor de 2 grados Celsius, y el agua que está saliendo por estas grietas en las que se acumulan estas comunidades de pulpos tiene temperaturas de entre 10 y 15 grados Celsius. Entonces la investigación tiene muchos propósitos. Uno es comprender primero por qué se acumulan por qué buscan estas comunidades de pulpos estos lugares para para fijar sus huevos y protegerlos por inclusive años que dura el proceso de gestación. Y ¿qué toman de estos medios? Si es el agua caliente, los nutrientes que vienen con el agua caliente, o si es un lugar donde se mantiene relativamente limpio la sedimentación, precisamente por la salida de estos fluidos que no dejan que haya una acumulación de sedimentos. Entonces todo eso es parte de esta investigación. La participación del observatorio en este proyecto es principalmente para estudiar en parte los fluidos que salen de estos lugares de afloramiento submarino de aguas poco calientes, pero sobre todo comprender un poco la circulación de agua dentro de la corteza y la cantidad de agua también que podría estar entrando en la zona de subducción. Esta región de montes submarinos que fueron creados en la cordillera medioceánica del Pacífico, cerca del Ecuador, y hace unos 23 millones de años esos montes se han desplazado hacia el noreste junto con la placa del Coco, y muchos de estos han terminado subducidos o introducidos por debajo de Costa Rica y de Centroamérica en general. El agua que entra primero con los sedimentos que han sido descubiertos también en otras partes del mundo a estas profundidades. Como pueden observar en las estructuras de estas rocas, se ven muchas grietas y este fracturamiento precisamente en zonas donde estos montes submarinos exponen rocas de la corteza, rocas ígneas, es donde se introduce agua en el sistema, en lugares en donde agua fría entra hacia la corteza a través de estos montes submarinos y tienen toda la posibilidad de migrar dentro de la corteza precisamente por ese fracturamiento tan intenso que tienen estas rocas. Y eventualmente el agua, cuando se calienta, es menos densa y buscará lugares por donde salir. No lo hará en las planicies abisales donde hay un sello de sedimentos profundos, de sedimentos marinos pelágicos, sino que buscará otras fracturas o otros lugares en donde el basamento o esa corteza ígnea aflore, y es precisamente a lo largo de otros montes submarinos. En algunos lugares se ha observado que inclusive en un mismo monte submarino pueden haber grietas y canales de entrada de agua, y ahí mismo también pueden haber grietas y salidas de agua caliente. Entonces, un sistema hidrológico bastante interesante y dinámico, principalmente controlado por la densidad del agua conforme se calienta, y esas diferencias son las que crean ese gradiente que hace fluir el agua hacia la superficie del fondo oceánico. Afloramientos de agua subterránea en el fondo del mar hay de varios tipos, y hay unos conocidos como black smokers, en donde es agua que viene de gran profundidad, de algunas decenas y posiblemente hasta centenas de kilómetros de profundidad, aguas que atraviesan, que vienen, que han interactuado con la corteza oceánica por mucho tiempo y salen cargadas de metales pesados como manganeso, hierro y otros minerales y compuestos, y va formando un precipitado en superficie que va generando unas columnas, unas chimeneas que sobresalen del fondo del mar, y con temperaturas en algunos casos superiores inclusive a 200 grados Celsius. Y en estas chimeneas o conocidos como black smokers se dan también comunidades de organismos, por supuesto no a tan altas temperaturas, sino donde la temperatura es menor, es donde se comienzan a dar estas comunidades de organismos también muy diferentes también a los que observamos aquí, pero es otro proceso mediante el cual agua de la profundidad del fondo oceánico aflora a la superficie y produce un ambiente favorable para el desarrollo de comunidades de organismos. En otros casos se presenta también afloramiento de aguas subterráneas submarinas en la zona de colisión, donde comienza a subducirse una placa por debajo de la otra. Esta placa viene con con una cubierta de sedimentos marinos saturados en agua, que cuando entran a la zona de subducción son compactados y esa agua tiende a salir por la pendiente continental, por el talud continental a lo largo de fallas. Y de nuevo son aguas cargadas en elementos y compuestos químicos que sirven de alimento para algunas bacterias sintetizadoras de químicos, se conocen como quimiosintetizadores, y esos microorganismos sirven de alimento a otros organismos y se va desarrollando toda una cadena alimenticia asociada a estas fisuras en el fondo del mar por donde afloran estas aguas subterráneas submarinas. En una oportunidad en 1994 tuve la suerte de bajar en el sumergible Alvin a más de 4.000 metros de profundidad frente a la península de Nicoya, precisamente en el talud continental, a mapear estas fallas por donde salen estos fluidos, y lo que mapeábamos realmente eran esas comunidades de organismos que se alineaban con los lugares donde habían estas fisuras o estas fallas en el fondo oceánico y por donde salían los fluidos. Entonces hay varios mecanismos mediante el cual el agua está circulando por debajo del fondo oceánico y aflora y se convierte en un mecanismo de sustento de la vida en el fondo oceánico. Esos montes submarinos en los que estamos trabajando, y en general la gran mayoría de los montes submarinos son producidos por actividad volcánica cerca de las cordilleras medioceánicas donde se está generando la corteza oceánica, y dependiendo del tipo y velocidad con que se dé el proceso de expansión del fondo oceánico o de generación de esa corteza oceánica, así será la frecuencia o la abundancia de estos montes submarinos. Y un caso muy particular y un ejemplo muy claro es lo que ocurre con la placa del coco. La placa del coco, la mayor parte es generada por la cordillera medioceánica del Pacífico Oeste, pero también una parte de la placa del coco se genera a lo largo de una cordillera oceánica más o menos orientada este-oeste, que se conoce como la dorsal de Galápagos. La diferencia es que la dorsal de la Galápagos es más lenta, y como es más lenta el material tiende a quedarse y hay una abundancia más de magma que produce una mayor cantidad de montes submarinos, y el fondo oceánico tiende a ser más rugoso que donde hay un centro de expansión más rápido.
Yeah. Okay. Good. I just realized it was dinner time, but your shift ends halfway through, so you can still get dinner. Okay.
So I just ask check if I'm not saying anything that is wrong. Hold my attention. I'll try to check anything.
That's fine. That's totally fine.
But I'll keep talking about the geology program.
Yeah, that's wonderful. I just noticed there's all this egg cement over here. These little green spots.
Mm-hmm. Yeah, there's some red patches too that I think are radiolarites. They're very clear in between the pillows.
Mm-hmm. What's that stringy stuff? What's that stringy stuff?
I don't know, but it extends along the suckers of the armpit.
Entonces, una vez más, estos montes submarinos son producidos en las dorsales, pero también hay otro tipo de, por actividad volcánica principalmente, y en realidad los montes submarinos son en su gran mayoría, si no todos, producto de actividad volcánica. Pero hay otro tipo de monte submarino que son los que se generan en puntos calientes, y puntos calientes son zonas en el manto, muy por debajo de la estenosfera, de la litosfera, que tienen un flujo muy alto de magma hacia la superficie, y cuando una placa se desplaza sobre uno de estos puntos calientes es prácticamente quemada, o sea, genera una actividad volcánica en un punto, y conforme se va alejando la placa del punto caliente va dejando una cicatriz de este punto caliente. Y un ejemplo clásico son las islas de Hawái, en donde la placa del Pacífico está pasando sobre uno de estos puntos calientes. En este momento la actividad está en la isla grande y se está desplazando la actividad se está desplazando hacia el este, hacia un nuevo monte o lo que será una nueva isla que ya tiene el nombre de Luigi. Pero si nos movemos más bien hacia el oeste, las islas cada vez tienen menos altura, y llega un momento en que la cadena de islas se vuelve submarina. Entonces eso es otro tipo de vulcanismo con montes submarinos, pero asociados a un punto caliente. Y en el caso de la placa del Coco y la placa de Nazca hay una situación muy particular, que tenemos un punto caliente que es donde están las islas de Galápagos, que por encontrarse ese punto caliente justo en el eje de uno de estos centros de expansión del fondo oceánico, entonces produce una cicatriz tanto en la placa del Coco como en la placa de Nazca. Y la cicatriz que produce sobre la placa del Coco es la cordillera submarina del Coco, que se encuentra en estos momentos prácticamente colisionando con la parte sur de Costa Rica e introduciéndose por debajo de la península de Osa. La isla del Coco es el único punto que emerge de toda esa cordillera submarina. ¿Esto es rojo o es verde? ¿De qué color es esto? Es que yo no veo colores. ¿Cómo se ve? No. ¿De qué color es esto? ¿Es rojo o es verde? Es que yo no veo colores. Vamos a ver nuestra cotilla. Café más o menos. Vamos a ask you if it's red or it's green. I'm sorry. Because I'm colorblind. Oh, yeah. So I don't want to brown, reddish. Más café.
So this is the last one we did, right? 13?
Yeah, but I entered the end, but it doesn't appear here.
Okay. I just want to make sure that it's for my notes.
De nuevo, estamos estacionados en el fondo del mar sobre el monte submarino El Dorado, a unos 200 kilómetros al oeste de la península de Nicoya, y en este momento estamos tomando muestras de agua, lo cual nos va a llevar alrededor de 2 horas. Mientras tanto se están haciendo tomas con las cámaras de las zonas aledañas a donde está el sumergible Sebastián posicionado. Si tienen preguntas o comentarios que hacer, lo pueden hacer a través de los comentarios de Facebook, y si son temas de geología, trataré de responderlos, y si son sobre biología, preferiría ni siquiera comentarlos por no ser mi campo de formación académica.
Make that an event and say, I logged it, it's not appearing. Okay, what am I doing? I am starting bottle number 9.
Passing the reflection of the eye.
Bottle 9.
Yeah.
They will do.
Yeah.
It's pretty cool.
Refraction.
Ask someone who's done more logging.
Yeah, I'm going to.
Esta expedición del Instituto Oceanográfico Schmidt a bordo del buque oceanográfico Falkor 2 y utilizando el sumergible Sebastian es un proyecto conjunto entre varias universidades de Estados Unidos, Canadá y de Costa Rica. En particular de Costa Rica está participando sobre todo científicos del CIMAR y de la Escuela de Geología y de parte de la Universidad del Opsicoriuna. A bordo tenemos investigadores canadienses, estadounidenses, mexicanos, bueno, por supuesto de Costa Rica. Hay un peruano también a bordo, y estoy tratando de recordar de qué otras nacionalidades más hay, pero sí es un grupo bastante diverso, no solo en nacionalidades sino en formación académica. La gran mayoría son biólogos marinos, pero también hay geoquímicos, oceanógrafos, físicos y químicos, hay hidrogeólogos, hay investigadores que trabajan con flujo de calor y, perdón, se me olvidó mencionar que dentro de los oceanógrafos tenemos también la participación del Departamento de Física de la Universidad Nacional con un oceanógrafo, Sergio Cambronero, que ha estado en otras expediciones, en otros buques, y también de esta expedición hubo una primera parte en junio de este mismo año en donde se se recolectaron muestras, se levantó bastante video y además se pusieron dispositivos e instrumentos para hacer investigaciones de más largo plazo. En esta expedición y en las horas anteriores estuvimos viendo la recuperación de algunos de esos experimentos y ahora estamos continuando con la toma de muestras de aguas y mediciones de temperatura en todo momento del agua circundante del sumergible.
It's here. So it was coming. Maybe it's just coming later.
Les comentaba antes que la placa del coco que se subduce o se introduce por debajo de la placa Norteamérica, bajo México, bajo la placa del Caribe en la mayor parte de Centroamérica y bajo la placa de Panamá en el sur de Costa Rica, tiene dos orígenes diferentes. Una porción es generada en una cordillera medioceánica, en un centro de expansión conocido como la dorsal del Pacífico Oeste, tiene una orientación más o menos norte-sur, y otra porción es producida a lo largo de la dorsal de las Galápagos. Es un centro de expansión más o menos con orientación este-oeste y separa la placa del coco de la placa de Nazca. Entonces tenemos una porción de la placa del coco generada en la dorsal del Pacífico Este, y es precisamente la que se subduce por debajo de la mayor parte de Centroamérica y por debajo de la península de Nicoya. En el Pacífico Central de Costa Rica y bajo la península de Osa se subduce la otra porción de la placa del coco, que es generada a lo largo de la dorsal de las Galápagos. Es un fondo oceánico bastante rugoso, muy áspero, con una gran cantidad de montes submarinos. Es la placa que se subduce en esta parte central y sur de Costa Rica es más joven que la placa que se está subduciendo por debajo de la península de Nicoya. En la reflexión y refracción de la luz de esas cámaras se ve claramente las zonas en donde el agua es más caliente. Se ve porque inclusive produce sombras en la roca. El agua caliente produce sombras que se proyectan por el infrarrojo y que nosotros no, en la luz directa no podemos ver la diferencia de calor, pero el reflejo de la luz infrarroja sí produce una sombra, que es lo que podemos ver en algunos casos sobre la superficie de las rocas. La inmersión de hoy es la primera inmersión de una serie de inmersiones que estaremos realizando en esta región de montes submarinos hasta aproximadamente el 12 o 13 de diciembre, que iniciaremos el tránsito de regreso hacia Costa Rica. Entonces estaremos aquí alrededor de 10 días haciendo inmersiones en diferentes lugares de estos montes submarinos, tanto en los lugares en donde está aflorando el agua como en los lugares en donde el agua está entrando a la corteza por otros montes submarinos. Uno de los mecanismos que ha probado ser bastante eficiente para determinar las zonas en donde agua entra a la corteza y agua sale de la corteza es la medición de flujo de calor con unas sondas que se introducen en el subsuelo marino, podemos medir este flujo de calor, el gradiente térmico, y determinar zonas en donde hay deficiencia o aumento de temperatura, y esas deficiencias y aumentos de temperatura están principalmente controlados por el flujo de agua. El agua es un mecanismo muy eficiente para transmitir el calor, y entonces en las regiones en donde tenemos el flujo de agua del fondo del mar penetrando entre las rocas hacia la corteza, vamos a tener un flujo de calor menor, las temperaturas van a ser menores que en los lugares en donde esta agua ya calentada por el gradiente térmico en la corteza y sale a la superficie del fondo del océano, va a tener un flujo de calor mayor y temperaturas mayores, por supuesto. Como parte de esta expedición se harán bastantes mediciones de flujo de calor desde el sumergible. Muchas de las mediciones de flujo de calor que se han hecho con anterioridad en esta zona ha sido haciendo bajar una sonda desde los barcos, sondas muy largas que entran por gravedad, penetran en el fondo del mar y dan información sobre este flujo de calor. Sin embargo, esta expedición se hará con una sonda corta que va a ser operada por uno de los brazos del sumergible Sebastián. De nuevo, las rocas que vemos aquí en el fondo y sobre las cuales se acumulan estas comunidades de pulpos son lavas en almohadillas, son de composición basáltica, son típicas de flujos de lava en el fondo del mar, y producen estas estructuras que se compactan. Una vez que se enfrían, se compactan, se fracturan y además crean mucho espacio entre los mismos bloques, y eso es lo que permite que haya un medio bastante permeable para la circulación de aguas submarinas, subterráneas submarinas. Al parecer, la misma circulación de estas aguas, el afloramiento de estas aguas subterráneas, de alguna forma evita la acumulación de sedimentos y provee un sustrato bastante limpio para que estos pulpos puedan fijar sus huevos directamente a la roca y sea más seguro su incubación.
No, but like how to do the logging.
Oh, like on the hard sheet?
Yeah. Like have you talked to Leo about what he's doing?
Yeah, let's do it.
Okay.
So, how can I?
This is different from the water.
You are just sitting on it's going to take
Okay, I got it.
and just
Okay, I'll make it anything. Have go get some dinner. It's good.
let me say Buenas noches, esto termina mi turno de transmisión. Los dejo con la colega Randy, que va a continuar, y sobre todo con una transmisión en inglés. Espero nos puedan seguir en las próximas inmersiones y quedan en manos de una bióloga con mucha experiencia, y la narración será toda en inglés. Gracias.
Because these samples take so long, to look at the log of what he's done.
Thank you very much, Mitch. That was Marino. He did a wonderful job narrating. And now we're doing a shift change and we're welcoming Randy.
We started it here and then you made a bunch of observations and we finished it here. Just set that number. Okay.
So we're at 15 right now.
Also, thank you so much for bearing with us with our internet situation. I am keeping an eye on all of this. I am aware that our quality is not super great at the moment. Our AVIT has been working for hours to try and resolve the situation. But thank you so much for bearing with us. And yeah, I hope you still get to enjoy some of the beautiful octopus footage that we're getting today. Okay.
Riding a bike. Thanks.
There you go.
I'm good. Zoph, how are you?
Good.
All right.
Okay, shift change here on the Falkor 2. Every hour on the hour, keeping Deep Sea TV alive and
Here's your
well.
pokey
Thanks,
stick.
J-Rod. Everyone needs a pokey stick. I'm Randy Rogen. I am a professor at Boston University, and I am psyched to be here on this Octo Odyssey. Flying to my right, I've got J-Rod, Jason Rodriguez. Want to say hi?
Hello.
Have you said anything more than say hello?
They hear me talk more than enough.
Not everybody. My kids are tuning in. They haven't heard you.
Why weren't they tuning in on the last cruise?
Because they were in school.
We were flying outside of school hours.
Okay, well,
Hello.
I'm still not going to get more than a hello from you. And Life with J-Rod. You know, we've flown together a lot. It's so fun. We also have Sophie, the multimedia correspondent for Schmidt Ocean Institute, and these two are making everything happen. We also have, let's see, in the back, Oscar and Julie. You guys want to say hello?
Hi.
Julie's doing
Oh, there you go. And it is an honor to be here in the beautiful waters of Costa Rica, looking at, well, here's the question really, what are we looking at? And it depends on which perspective you're coming at it from. If you're Julie in the room, you're going to tell me that you're looking at microbes in water, and you're not wrong. If you're me, we're looking at this beautiful sea pen right in front because I'm a coral girl. If you're Oscar, you're probably going to look at the rocks behind. If you're interested, there's also a cool little coprellid amphipod that's hanging out in what I think is a bryozoan right behind us. Right? What do we got here? If you are Janet, you're going to be thinking or Theo, you're going to be looking at octopus. So really, what you're looking at is completely a matter of perspective.
There's a lot going on right here.
There's a lot going on right here. And if you're J-Rod, you're looking at the controls and the robot. Sebastian, right? Pretty good. All right, so we are parked and hanging out and standing still because we are doing something very, very, very cool. Julie, in the back, is laughing. Julie Huber from the Woods Hole Oceanographic Institution is trying out her new SUPR sampler on Sebastian. Is this the first time this has been on Sebastian?
First time mine's been on Sebastian.
First time Julie's has ever been on Sebastian. And what it is doing is filtering water. This may not sound like the most exciting of activities, but let me assure you, you are wrong. This is extremely exciting. Not only has Julie and her amazing engineering partner, Amanda, gone through a massive amount of effort with the entire ROV team to get this mounted onto Sebastian, but they've done this so that they can sample the microbial life that makes probably a lot of other life right around this incredibly, phenomenally cool Dorado seamount possible. So, Julie, you want to add to that? Probably do a better job than I have.
Well, and we're also bringing unfiltered water up to the surface to do experiments with to figure out their activity, so what they're doing in the ecosystem and how many of them there are. Like, we don't even know how many microbes are in these fluids or living on these rocks.
Okay, so this massive amount of tubes that, hang on, wait, whoa, don't go.
I'm just going to go to the other side.
Oh, no.
Okay, I'm like, that's pretty cool. You can't just leave. Look at this amazing job. That's pretty epic.
Yes, it's
This
an organizational nightmare.
It is, it's pretty cool though. A lot of things. It's, you may think a lot of these the equipment that we're looking at and using is off the shelf, but you really can't go to Home Depot and buy these things. You have to make them, and so there's a lot of homemade, home engineered, custom built, completely bespoke technology that is engineered for the singular purpose of whatever science is happening. And so what you're looking at is not just a bunch of tubes, you're looking at a highly organized, highly sophisticated, long dreamed of set of tubes that is now working actively on the seafloor. It's pretty great. What's your favorite piece of tooling that you've put on here, J-Rod? Oh, look at that. Come on, that's a masterpiece. There's so much to be proud of there.
Never seen them down on the seafloor.
I don't know.
Okay.
Catching fish with a fish net was really fun.
Catching fish with a fish net is really fun.
That was a sampling device.
As a sampling device. All right. So
Four-
going
4,400
net sampling, like a
meters.
butterfly net almost, but with Sebastian. That's pretty cool. 4,500 meters, you said?
44.
4,400
Just
meters.
at the edge.
Just at the edge of the range, so going in as deep as you possibly can. Cool. What about, do either of you have a favorite piece of tooling?
On the seafloor? That's a good question.
Piece of technology you've used? What about you, Sophie? Coolest thing you've done, seen, witnessed, dreamed of?
There's been so many. I'm not kidding. Like, that's, it's really difficult to decide. I think I'll need to think about it for like 5 minutes.
Okay, 5 whole minutes. That's a lot of, I guess you've got a large inventory to sort through.
Yeah.
We once used an old coffee can that we attached a ladle from the kitchen in to scoop up lava.
There you go.
Whoa.
Highly technical lava scooper.
You win.
Perfect.
And it worked.
I love it.
What about you?
Me? My favorite is actually Coral Push Poppinator 3000. Which is something that I think you and Cody devised way back in the day.
Oh, yeah.
It was a set of syringes to real time try to feed corals in the deep sea and see what they did. What about you? Got a favorite? I realize this is all.
Well, this is my first dive.
Woo woo! We won! First dive!
First dive. I guess I'm really loving the camera. Like the fact that it works super well down there.
It does.
Amazing. Yeah.
Well, that is, the camera does work pretty well, which means that I should probably use it. But before I do, we have a little bit of information to tell you. I see some questions coming in about the biology, and had a geologist at the helm, and now we're talking about technology. But I want to show you this amazing water shimmer that you see. Can you guys see this coming across? It's pretty great. That is from the hydrothermal spring, I think, kind of coming up. It's just it's kind of great. You think about sort of invisible stuff in the deep sea, and it's invisible for so many reasons. It's dark. It's super deep. Let's see, how deep are we? Right around 3,000 meters below. But it's you know, what you're seeing here is also a lot of invisible activity that's coming from the seafloor itself. We are on the Dorado Seamount, which is about 20-ish million years old, 23, I think. And so it's a very ancient, you know, old volcano, not active anymore, but you're seeing some hydrothermal activity, which is what makes this octopus garden possible. They are all here, we think, taking advantage of the warmer water, which is pretty exciting. Okay, so can I play with Zoom? Or is that going to drive you crazy? You sure? He says that. He says go ahead now, but we'll see what actually happens. Oh, my kids have asked for a very special hello. So Zoe and Xander, hello. It's their first dive of this expedition too. Oscar, you're number one. Woo! Actually, it's all of our first dives of this expedition.
Do you want to wave at them?
How can I wave at them?
I can, hold on, wait. I can turn on the CCTV camera. Just give me like 2 seconds just to make sure.
Julie, are your kids watching too? J-Rod, yours?
Oh my God, my friends are watching.
Kids, what?
My friends are watching.
Your friends are watching. Well, then this is your first dive ever. You definitely need a big hello. Sophie will tell us when.
Yeah, I'll tell you when.
Go ahead and play with him. I'll watch you.
Oh.
Don't worry, I'm not
Oh. Well, I'm just going to get yelled at. Oh.
I'm not flying.
You're not looking at us. I know. But you know me. Oh, Max zoomed in.
Maximum effort. This was my favorite.
What's your favorite?
This octopus right here.
This octopus?
In
This
this
one
area.
who's covering his or her, I think probably her eyes, so that...
She wants to get some sleep.
I feel like that's a he because it's not in that position.
That's true.
protecting
It could be.
But I can't see the lake.
The shimmer makes it extra great.
I'm flying it. Also, I have the CCTV set up if you want to go say hi to your kids.
All right, let's do it. Let's do some hellos from the control room.
1. Okay, go say hi.
Where we go? Hi! Oscar's first dive.
Yeah.
My sweet monsters.
Monsters.
They are. Sometimes they're cookie monsters.
I like it.
Sometimes they're all kinds of monsters. All right. All right, well, we are sitting here, which gives us this incredible opportunity to zoom in on what we can see. And this is great because it's my first dive in Costa Rica, too. I usually work in the equatorial Pacific, and this is a great opportunity to look at an ecosystem that I don't typically get to see. So let's spend a little time. Oh, you're looking at me? I'm looking at you. Oh.
You see Sebastian in that ball?
Yeah, oh, yeah, wait a minute. So you can see Sebastian, you absolutely can, in the eye of the octopus. Oops, ooh, who put me in charge of this thing? Hang on, it's just gonna take me a minute to get that's about as close as I can zoom in, but that is a great shot of us looking at the octopus looking at us.
Definitely has his eye on
Well, he's got his eye on you. All right, let's take a look at that so we can see it in the seafloor. So one thing that I always like to do when I am zoomed in close is look for, well, either animal interactions, because this is an incredible opportunity to just sit still and look for behavior, which is a chance we don't get very often on the seafloor, and to look for coral recruits, or these tiny little anemones, or all of these little things that usually when I zoom in on, people get frustrated because you want to spend all this time exploring. But really, Julie, I owe you a big thank you because this is one of my absolute favorite things to do, is just to sit and watch the interactions on the seafloor and then ponder about what we're seeing and why it might be. You know, this is a great time to think about new hypotheses. Oh, see, look, there's a shrimp right here. We might see some shrimp octopus interactions.
They're mean.
What?
They're mean.
They are mean.
You ready to focus that on the trip?
No, I'm moving all around. I'm just kind of trying to see what I want to look at. I'm gonna.
Coral recruit. Is that just baby coral?
Baby coral is a coral recruit. I haven't seen any yet. So far, I'm looking at those dots of little anemones.
Are those anemone recruits?
I think those are full-size anemones, but yes, they have recruited there and have stayed. The reason we call it recruit is because they had either a planktonic or at least some kind of mobile phase, and they've picked one spot to stay still, which is kind of cool. Oh, hey, there's some friends of mine tuning in too. I see Julianne Mueller-Northcott coming in from New Hampshire, I think. So hello to Julianne and her students who may be looking at this at some point. All right, what do we want to look at here? We've got an active octopus, right, who's swirling around right below us. Maybe we should take a look at that. What do you think?
Mm-hmm.
Hey, Randy.
She.
Yep. She.
We have a request from Andy.
Well, oh, what's Andy? Go for it. What's your request?
He's right behind you.
Hi.
Hi.
As part of the dive plan, we had a note that if it didn't interfere with things, we would turn on the heat flow probe and do a quick test to make
That
sure
would
that
make me
works.
very happy.
Yeah?
Yes.
Okay, I'll get my computer. And I'll come back.
That would be wonderful.
Over here.
Yep. I'd just like to wait until she's in between samples, just in case it does anything, that she's done with the sample before we power it on. Is that okay with you, Julie? Just
Yep.
let me know when you're in between them.
Okay, I can stop this one anytime in the next 5 minutes.
Okay, the computer.
Okay.
All right. So we have I am not an octopus expert, so I am not exactly sure what we're looking at here. Is anyone in the room know what kind of behavior we're observing?
That's a female protecting her eggs.
Female protecting her eggs.
And a male, we don't know if he's protecting.
No, Janet wasn't sure.
Yeah, nobody knows.
She thought maybe some of these ones that aren't brooding are looking for a place to brood.
Oh. Okay, but that one could be brooding. We just can't see the eggs, though, right?
Yeah, could be.
But there's some that don't have eggs right now.
Yeah.
And then the male, we just don't know if they're like territorial or whatnot. Like, well, yeah, that's also in there.
Okay. So, but any idea for sort of why the flurry of activity?
What do you mean by flurry of
I
activity?
think it's just squirreling around a lot and then just kind of maybe aerating eggs. I don't know.
Yeah.
We don't know.
Yeah, there was a lot of talk about that last time we were here.
All right. Well, that's possible then. So this is one of those moments, right? While Andy's setting up and we're moving around, we get to just kind of pan around and look for behavior of octopus, of shrimp that are moving in, and it's pretty cool. So, behavioral biology is something that's really, really common in shallower waters, to sit and watch for hours, watch animals behave. And it's a luxury we just don't get in the deep sea very often, because it is hard and expensive. Every minute that we spend on the seafloor, we need to move. We have things that we have to, there's a lot of science to be done. Behavioral science is absolutely science as well, but we're at the point where we're still trying to see features for the first time, or name species for the first time. And so there's literally a lot of ground to cover, more ground here than anywhere else on planet Earth. Down to the point where, we're sampling microbes, and Julie may have seen some of these species before, but there's probably a lot that are going to be new to you and new to science. And the interactions between, the water chemistry, the geology, the biology is unknown. And so again, what may look to you like octopus, octopi, octopods, octopuses. Has this expedition come to a conclusion? I don't know. Are just standing here. We're looking at small amounts of movement, and remember that every bit of movement in the deep sea requires energy, and energy is pretty hard to come by in these environments. And so any movement we see is probably meaningful and is worth doing. And so the lack of movement also signifies a really smart strategy to not waste energy when you don't have to.
Yeah.
Any other thoughts there might be other reasons, other things that we're looking at. Andy, are we?
I'm just getting plugged in,
okay.
So I'll be another 2 minutes.
No rush.
They're not going to need the camera either, so you can keep using the camera.
Okay, so I can keep playing. Excellent. I'm going to take a look at this.
I love your explanation of the whole, going to a national park at night with a flashlight.
Oh, yeah, I do too. So
I use it all the time.
J-Rad and I are just having a little chat. It's not even mine. My friend Jan Whitting, the first time we sort of started talking about the deep sea, he's a biological oceanographer who works for the Sea Education Association. And we were chatting about, the way deep sea exploration works. And it really is like climbing up a mountain on one teeny tiny trail, at night with nothing but a flashlight. And Sebastian has pretty incredible flashlights, but we're still hiking up one teeny tiny little trail at night with nothing but a flashlight, and in this case going on a trail that we've seen before, and still measuring and studying and noticing and describing new things, which is really exciting. I really like these coprelids. They're so cute. They look like cocopelli to me. See them?
Sure.
Like kind of bent over.
Oh, yeah.
right? And I saw one before. The reason I came in was because it actually, I saw one of these other little amphipods kind of come close to it, and it just kind of punched it out of the way. And so I'm zoomed in, kind of hoping we get to see a little interaction.
It looks like a stalked praying mantis.
It does, doesn't it?
Okay.
It's awesome.
Yes, ma'am.
Will you please power up the heat flow probe?
Roger that. Heat flow probe is on.
Okay, thank you.
So what's happening is that Andy Fisher is in the
Joey,
room.
your com's still good?
Hello.
I turned off my pump.
Okay.
But I'm still getting X.
Okay.
And Andy is working on his OsmoSampler, or no, heat flow probe, right?
Yeah.
Heat flow probe, which, Andy, why don't you explain this?
I just got
Or when you're done. Nope,
yeah.
you're busy.
Yeah.
Yes, and I got a ground fault on it. It's not massive, so you can keep doing what you're doing.
Okay.
All right, we're gonna be quiet and let everyone focus on what they're doing.
Are you good to go?
Are you sure? I don't want to distract anybody. All right, well then I'm gonna look at this adorable, or as my daughter would say, adorbsable little sea pen. Adorbsable. Look at that, it's so little. That's a recruit.
It's running, but its temperatures are awfully high.
What is it?
It's around 4.5 degrees. I don't know where it is.
It's here.
Right there?
Yeah.
Here.
I'm getting a bit of ground fault, and I don't know how it's reading. Those thermistors are getting red, so if there's a little ground fault, might be giving you a little bit off temperature.
Yeah.
Hey, Oscar? Yeah. For that sample
Definitely
that
doesn't
we
look
just
like
saw,
I expect. Let me record a few more data points.
So while you were looking away, you may have noticed this little guy moved. This is some kind of bivalve.
They're both pretty smooth and black.
Yeah, they're
Just closed.
This was about 18 liters.
Yeah,
18 liters.
Yeah.
sitting still. There's all kinds of stuff.
Well,
actually like
not a
close
little
here.
bit. What are they called?
This might be a limpet. I've been looking at that. It's kind of limpet-like, but this I saw just contract. So I think it might be some kind of small bivalve.
We did this one cruise, and we were sitting working for a long time. We got a small camera in front, and it was just looking at the mussels that had
Just as
them
a
all
note,
over
yeah.
their shells.
18
But when you
liters.
fast forwarded,
I mean, they are attracted to each other, so that's
Oh, wow.
but if you looked at it real time, they weren't doing anything. But when you fast
Yeah.
forwarded,
So I
they
didn't
were
fire it.
attacked.
003.
I bet it's the same with the octopus, to some extent. Although, like I said, it's
No.
energetically
Well, they can't
wasteful.
move because
No, but they
their
can
eggs
move.
are
But they can
doing
move their tentacles, right? They can have readjust, have some
Plenty
positioning.
of water.
I mean, goodness,
J-Rod?
if I was a
Yes,
brooding.
ma'am.
Are you okay with me running my?
I am. Just let me know. Like, make sure your comms are good and everything.
My comms are good.
Yeah.
Yep.
Oh.
I was able to move the valve.
Then.
So you're okay with me
then-
starting the?
Yeah, I just didn't want him to accidentally knock something out while you're in the middle of
Okay.
sampling. So.
All right. So I'm now starting filter 12. Oh, look at it. It's like trying so hard.
It's spinning round and round.
It's a different material than the other one.
Look, he's opened up.
Let's see where it goes down.
Yeah.
Wow. What is that thing?
I don't know.
Thing is,
Some
the
kind of
water
bivalve.
molecules move very quickly.
I can't
Yeah,
zoom
there's
in
water moving by.
anymore. Can you?
Just get
That's-
closer to the screen.
Curious.
Oh. Here, I'll put my reading glasses on. What's that? Just it's pretty cool.
Should probably think about putting the other one on.
Right.
If there's a ground fault anyway, then we're going to want to look at that.
Yeah, it could just be our cable. It's a dry cable, so.
It's hitting temperatures that are a little bit too high.
Yeah.
A couple degrees warmer than I expect, so we're definitely going to look at it.
Okay.
But I'm gonna stop logging.
So, before I just come away from this thing, you can see this bivalve in the center has
Pretty much comes back to the same.
opened up. Oops, not center anymore. Wrong way.
UTC
God.
time where it's
So he's
Doing great.
yeah.
Proud of you.
Shush. This is what happens when old friends get to fly together. Yeah. Well,
There's a lot of noise.
it's definitely a bivalve.
Anyhow, I think we're going to go with the other one.
That's all I got for
Yeah.
you. Can I move on?
The
Feel like I don't know, can you?
So Rachel ended up, she thought it was 9, but she checked.
I would have
it was
sworn it
a
was
different tool. So
There's another one up here. See? Wide open.
yeah. And the thing is, this is going to be up at
That's my favorite thing. You get to look.
That one right there.
Yeah.
And then they're going to
Where?
The one that you pointed at right above.
Yeah.
This
So it
this
doesn't
one?
leave a
Yeah,
big
both of
window.
those, yeah.
I don't think I can zoom anymore. I'm at max zoom. Where am I going to get my closest shot? I bet you they're all over the place.
With everything else going on.
Exactly. Shoot.
Aha. Here we go, right in front. There we go. Boom.
So he's looked it up and.
See him?
All right, we are all done. Please power down.
Roger that. Heat flow probe is coming off.
That's it?
Yeah, well, it ran, but data looks noisy.
Yeah, I really do think it's because that ground fault. Yeah, ground fault's gone away. Okay.
Oscar, you got the start of that next one too?
No.
Oh. It's started a few minutes ago. Filter number 12 started at 0023. Yep. You got my ground fault gremlins.
Yeah, I guess so.
Sorry.
Okay, not your fault.
All right, let's keep zooming a little bit around here because I think it's pretty cool. This is the opportunity to kind of see what we can see all the way around. I just don't want to distract anybody else, but while we're going, let's take a look. And look at these little anemones that we've got going on.
Just so we know for microphone.
There's one right here in the front. See?
Where's the location for that?
Same place.
Once I heat my fish tank.
Oh yeah, I know exactly what you mean.
Maybe it starts with an A.
Yeah, it'll come to me. Aptasia.
Aptasia.
Yeah, I'm like my head. That's different ecosystem, different world, right? Oh, look at this little amphipod kind of curled into the rock, pretending that we can't see him. So I think it just is amazing to me every time I get a zoomed in look like this. I think a lot of people think that the deep sea is barren or doesn't have a whole lot of life. And if you're here at the Schmidt channel, you know that there's a lot of stuff here. But we often stop and look at the big stuff: the lions, the tigers, right? The big redwood trees. By that I mean, of course, the octopuses, the sharks, the cutthroat eels, the corals, the sponges. But when you zoom all the way in on this, it really is this incredible opportunity to realize just how much life there is. I mean, really every surface is covered. And if you can't see it covered by an animal, then we know it's covered by a microbial biofilm. And this diversity of life is really understudied, again, because it's so hard to spend the time to really, look at this piece of it. And one of the nice things about this expedition is that amidst this incredibly beautiful octopus garden, there is all of this, other microbial life, smaller life that we get a chance to look at. It really is a luxury to be able to do this. And so here we are hanging out with a mama octopus, brooding her eggs, spending a little time with her on her journey, and getting a chance to see the world that she interacts with every single day. What?
It's the end of her journey too, right?
It is the end of her journey. I don't like to think about that part, but it's because I think of it as the beginning of her offspring's journey.
Okay.
Half full.
Although this might be a male.
Way to burst my bubble, J-Rod.
It's my favorite one. It's the one that's all curled up.
Fine. In pursuit of truth.
It seems that both males and females
Ooh, we have the
We got that
octopus expert in the room. Janet, do you know if this is a male or female?
I can't tell. It's the third right arm, which is what's hidden by the octopus.
Ah, well then J-Rod, it will remain a mystery. We can argue about it as much as we want. Until Janet definitively gives us an answer here. What shall we look at?
You could write in the log that for all of these.
Oh, here's another little sea pen.
Temperature has been
This one might be
between
better.
about 9 and 10.5 degrees.
Yeah. It's almost like
You can just
I'm going
write
to
it
zoom out here and see what we want to zoom in on.
Like a running commentary,
Randy, that pink one is a male.
The pink
Check.
one right in the middle?
Yep.
Pretty exciting. There's a lot of eggs. That's what all of these female octopuses, or octopods are doing, is brooding their eggs, and one of them just hatched. And we're looking at a brand new baby octopus.
Amazing. Happy birthday.
Happy birthday. Oh, look, we got an octopus shadow. This might be the only time in that octopod's life that it gets a shadow.
You're right.
Birthday shadow. Bye. Off into the world.
Okay. 5.2.
Yeah, he's still quite a ways up. That's a good thing. That means he's going in the right direction. Or, yeah, where that shrimp is at. Be mindful of that.
I wonder if we'll get another baby. We've had a few today. This is the first dive of this Octo Odyssey 2 expedition. We're here with the Schmidt Ocean Institute aboard Falkor 2, Octo Odyssey 2, and we've had at least 2 babies so far.
Okay, I'll take over. I want you to be able to get some sleep. Alright.
Pretty exciting.
Let me know if the temperature starts rising pretty good.
So what we're doing right now is repositioning our
Right for that.
inflow pipe, essentially, to the SUPR, which is sampling water. And we're trying to get to the hottest water we can find. Costa Rica and a number of institutions, really, taking a look at all of the various animal and microbial life and describing it in many cases for the first time, or giving us a much better understanding of how these animals interact on the seafloor. This is a really good shot. Oh, he's coming out for us. Again, sitting still so that we can use the SUPR, but what an amazing opportunity to get a super close look at the seafloor. We're seeing all kinds of things that otherwise we might have just zoomed past, and we're getting a chance to see how they behave or not. And that lack of behavior is really an energetic strategy to save energy, which is so hard to come by here in the deep sea. When you think about it, right, we're seeing quite a diversity of life right here in just this little spot.
It's awesome, honestly.
He came with the hose and everything when we stuck it in. Did that one.
Okay.
Said it was mine.
So this squat lobster is definitely looking like he'd like some privacy. So we'll give it another minute.
I want to know which clutch of eggs these 2 babies have come from.
I was wondering if we could see any more. Have we on the last expedition? Did you see hatching like straight out of the?
Yeah.
Amazing.
But almost every time they were getting attacked, though, right? Almost every time.
You mean, what do you mean?
By the shrimp.
Yeah.
Yeah, but this is twice that nothing's come after it.
I think that weren't they like unique circumstances when the shrimp grabbed onto them?
Possibly. I mean, yes.
Related to us.
Did we have any that were just natural, just?
Yes, lots.
Okay.
Yeah.
So we have Diva Amon, who just came into the room. Diva is what? Oh, we've been introducing everyone as they come in the room.
Sure. I mean, we're going to do megafauna sampling soon. So yes, sure.
Do you want to let me do it, or do you want to do it yourself?
We're going to get sick of her.
All right. Well, let's take a look at here. Diva is helping us with megafauna sampling and some big transects and all kinds of stuff. They're great. So I'm looking for
Good. How are you?
cryptic things that we may have overlooked previously, right? Because here's our chance to look closely. So what do you see that you may not have noticed before? Let's play the game.
I will just stop this one at 7.
Okay.
It's fine.
Just this one, or you got a couple so far?
I got another one.
Oh, this might be another one of those.
And I'm getting here.
Yep.
You know,
See the
stuff's
green
not
stuff over
clogging
there? Is
I
that just
do.
the cement from eggs?
I think so. There's no way it's photosynthetic. We're at 3,020 meters below the surface. But yeah, that's a good hypothesis.
Janet, is that old cement?
These little patches in the rock?
The green stuff?
Yeah, egg cement.
Egg cement. All right.
Look at the eggs on that shrimp.
Yeah. Well, I was looking at the feet on the sea pen, but the eggs and the shrimp, same deal. Pretty amazing. Might be somebody else's birthday. Shrimp birthday too.
Every 14 days?
What?
Every 14 days.
Every 14 days. Is today the day?
Well, in my tank at home, every 14 days.
So was your hour animal person for an hour?
So one day in this expedition out of 14.
It's crazy to watch them.
Is that what happens?
Millions.
What?
Millions. It's crazy.
You've seen it?
Huh?
You've
Yeah.
seen it?
Yeah, they grab onto the fan, and then they just start letting them go, and it just takes.
That's pretty cool. All right, so I'm pretty interested in this. I'm taking a look at this shrimp coral interaction here. So one of the things that I'm really interested in is coral predators, and I'm not suggesting that this shrimp is doing that. But ooh, did you see that other little guy? Yeah, little amphipod that came off the backside. But I'm pretty interested in watching how this coral reacts to being.
Sea pandas.
Yeah.
Do you remember sea
Same as
pandas?
this, like
No.
sweep everything.
Me and Cody renamed sea stars into sea pandas.
Oh, that I do remember.
Because they eat bamboo.
They do eat bamboo. This is
This is
not a sea panda. This is, what is this?
Looks like a shrimp just helping out the coral, cleaning off some sediment.
Yeah.
Being nice.
The coral's not retracting though, or doing anything. It's just sort of hanging out and letting it happen.
Not disruptive. I bet you anything if we touch it, it would react.
That's right. So it's pretty interesting. It's differential response. Shrimp hug. That's a good way to put it.
Yeah, like I've noticed that in my tank out. Like we have shrimp that hang out inside the coral. They don't retract. They don't
Exactly.
close their polyps or anything, but
If we touch it, yeah, it certainly knows. So, you know, corals are animals, and so I know they look like plants, but they are truly animals, and they have behavior. But this one did not really look like it moved too much. It did knock it over, and it looks like some of the polyps look a little discombobulated. They're not sort of outward the way they normally would be. So, oh goodness.
I did not do that.
If a sea pen falls
I got
in the middle of the
video evidence of
volcano.
caused this.
You sure?
She was a little bit heavier than she thought she was.
Hey. Hey, hey, hey. Hey now. Mama shrimp. Oh, we have Steve Askovich joining us. Dr. Steve Askovich is an amazing coral taxonomist, and maybe. We're so close. No. And I'm delighted to have Steve join us. I was just on Steve's a postdoc at Boston University, and we were just in a lab meeting together talking about his work on eDNA and deep sea corals. And here he is, helping us out. Hi, Steve. I'm so glad you're here. He is one of our shore collaborators on this expedition. All right, let's see. Where shall we go?
Hey, Randy.
Yeah.
Can you take Science Cam to the intake? Just so
Sure
I
can.
have it for the record.
Yep.
This little-
J-Rod's gonna bail me out here.
Okay. What's that? Another temperature thing? Oh no, that's the marker.
That's what I would have done for the record. I would have zoomed out and zoomed around and found it. Just so we're clear.
All right, we are in the shimmer.
Definitely.
Definitely. Okay.
How's that
Cool.
temperature looking?
It's been great. It's higher than before. Closer to 10 and a half, 11. Thank you.
No worries.
Ramming it in the rocks, you know. That's why I put that little grid on the end so we could stuff it in rocks.
Oh, the squat lobster's out and about. See him? Right here? Dun, 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 dun.
Oh, yeah. So he's just camera shy. He knew we were looking at
Yep, let's take a look at the sponges at the top of this. Can we get in
it.
there?
Yeah, you talking about the wedding sponge?
Any of these? Yeah.
Sorry about that.
It's a nice hectactinellid. It's cool. Sure.
It's all yours again.
It's just about time for a shift change again in a few minutes.
Yeah, that's right.
Right?
Just trying to remind myself what's happening. Yes, you're right.
Okay.
Have you seen any?
No, but we haven't been able to.
Yeah, yeah. Okay.
It's been like these little rock pens or sea pens and some hectactinellids.
Checking out anything here?
There you are.
Ooh, there we go.
I knew you were around.
And the next up, opportunity is to go get specimens.
Okay.
First thing we're gonna get is a Randy, so she's not gonna go very far.
Right.
And
That's an eagle, right?
Actually, can we revise?
Sure
that?
is.
So there's not primnoids around here, but we do have sites on a SOI fish, which was our second priority.
Okay,
So if we
that's
could just
fine.
like flip,
That's fine.
because it's literally like right where we are right now.
Yeah, yeah.
I don't hear you, Randy.
Yeah. Let's do what's expedient for here.
Yeah, because primnoids, like, we'll have to look, and we honestly don't think we're gonna find any primnoids.
Okay.
I think that's okay. If we find another species that works, maybe I'll call it out, but you should get the priority while it's here.
Are you the one suggesting Arizona coming in here for specimens?
I can get her to come, but Bia is also gonna come as well.
Okay.
I'll just tell everybody, we're
gonna be specimen experts, giving you
Yeah.
guidance
Good.
on what we're gonna collect. So as we're need to narrate what's happening, we'll talk about what you studied, got on it.
Okay.
Say anything.
Camera shy.
What? Camera's me? Alright, I'm gonna zoom out. So here's my chance. We've got a shift change coming up pretty soon. And what's gonna happen is we're gonna do some sampling that needs to happen, and we're gonna switch our priorities around based on what we see and what's available. And this is really important to be able to take advantage of where we are, especially if you're looking for something mobile like a type of fish, because you just don't know when you'll see one again. And so this is a really great opportunity for us to be able to do that. There's a couple of squat lobsters, right? See, here's another one. And then afterwards, we'll fly around and look for some corals for me. So Steve, if you're listening to this, stay on for the next hour, because I think your advice will be really helpful. But I think that what we'll do is finish up with a super sampler and then start some collections, and then while we're looking around for corals, for me, we'll probably do a little bit of flying, and if we don't, that's okay too, because this is dive 1, and that is, and flexibility is a major part of working in the deep sea, and there is a lot to love here. We have seen at least 2 baby octopuses, 2? Just two. We have seen some really interesting behavior. We've gotten some close looks at the seafloor. We've seen some incredible technology at work. We have all gotten our sea legs back. First dive, figured out how to do this again. And for me, this is my first dive aboard the Falkor 2, and it's been pretty exciting to pick up a camera that I have used before, but in a totally new setting. And so thank you so much to Wendy and Eric Schmidt and everyone at the Schmidt Ocean Institute for enabling this incredible look at the seafloor. This is an incredible privilege and honor to be working with everybody who makes this expedition happen, from the chefs to the stewards to the bosun to the ROV pilots, marine technicians. I know I'm forgetting stations, but literally everybody who outreach and communications people. It's just it takes a massive number of people to make an expedition like this happen, and this is dive 1, and here we are. It's real. It's just been months in the making. All right, so I think it's ready to hand over. I'm going to leave you in the very capable hands of Andy Fisher, and I'll see you guys tomorrow.
Thank you, Randy. All right. That was Randy. We're doing a bit of a watch change. I'm going to let him get settled a little bit here. let us know if you have any questions, of course. We have another dive happening tomorrow morning. Just a little update for you, and then we're going to be back on deck for this dive at midnight tonight local time. Okay, and now I'm going to pass it over to our new watch lead.
Change here in the control room. Randy Rutgen is done for her shift for the evening. And I'm Andy Fisher from the University of California at Santa Cruz. And I'll be here for the next hour describing some of what is going on. But I am not a biologist, so I'm going to be learning along with a lot of other people who are watching the activity.
Anything you want to look at?
Gosh, I don't know. You want to check me out on this? Go ahead. What do I do?
So right and left are normal.
Okay.
Pushing forward actually goes down.
Okay.
And then rotating this is usually.
Ah, okay.
So clockwise is in.
Yep.
Pretty much all you need.
I don't need to touch that.
You don't
Okay.
need to touch it.
Great. Great. Wow. Gosh, what should we look at first?
Typing things here. I like that.
Yeah.
All right.
Like it's just events.
Yep.
And just a brief description of whatever that event is.
Use that spreadsheet that you're working on. Cool. All right. Let's just. All right. Yeah.
I didn't see it, so I'm glad you did. No worries. I'm gonna try this.
Zero. Yay, I clogged the filter. Woo.
Nice.
A little bit of excitement here in the van. Julie Huber has been testing her super slurper sampler. And one thing she wanted to try out was figuring out how much she could pump before she clogged a filter. And she's excited that she succeeded in clogging one of her filters.
Stow the super.
Roger that. I need to take the camera.
That was disturbing.
So, stop it. The clock.
We had a glitch. It glitched twice.
Oh.
And then it catch the very fast.
Oh, that's not a good default.
It just should never, like, what
As we finish up with the sampling operation, we're going to be moving on to some specimen sampling.
I'm guessing that was about 3 liters.
It looks like we'll be collecting some coral this evening and potentially some echinoderms and possibly octopus eggs. It was pretty exciting earlier in the evening. We've seen 2 recently hatched baby octopus so far. And that's exciting. When we found this area back in 2013, there was concern about whether or not the eggs would be viable. It appeared, at least initially, that many of the octopus eggs did not contain living organisms. They looked like they were empty. It might have been that was just the early stages of their development. We're not sure. But when folks came back here in June of this year, they were excited to see eggs with what appeared to be viable organisms inside, and then later in the expedition to actually see newly hatched octopus. They're very cute. The pilots are now stowing the intake for the super sampler. There's a place for everything, and everything has its place on the tray. Sure.
Super is going off.
Thank you.
Thank you.
Super off. Hey. I'm well. How are you?
Really good.
Good.
Are you ready to start the bio?
I guess. Yeah. I don't know what I'm doing.
I want
What
to
we
try
doing?
first. There's a fish. Just
With the one that was sticking up a little bit?
yeah, exactly. Like between this one and the other one, there's a fish.
Oh.
Beneath that rock.
Okay.
We want to try to start with. I don't know. It's too much.
I think that's what happened. I wonder
It's not too much to add.
what happens.
Yeah.
It's gonna be a tricky one. That's for sure.
Yeah. Okay. So
That's the most
sure
likely
that's on the species.
scenario.
Right.
Yeah?
Not sure
Okay.
because I haven't seen it.
No, but there's probably almost everything that gets in this fish, right? Yeah, that's
It's a
what.
good one.
Yeah. Our pilots are now getting the sub set up so that we can commence with sampling. The key here is to find a spot where they can set down and be stable, and where the manipulator arms will be able to reach. So they're just getting everything configured to try to make the sampling easy.
Hi, Joe. Take a picture.
Call it.
Yeah, he was on the last cruise and he tried to fix the SUPR. So he's pretty excited to hear it's working. Oh my god, all the biologists are here. Better get out.
And out here on the Falkor 2, we have a control van just full of biologists. The interior of the van looks like the rock covered in octopus, only instead of octopus, we have biologists. Yeah, Julie is very happy with so far with the performance of the SUPR sampler. Looks like it worked pretty well.
Doesn't look like I'm gonna be able to use the section sampler.
What?
Because the jar is not indexing.
So no suction sampler for the dye.
I might be able to try to wiggle it loose, but I'd need to come up and thrust around pretty hard. Yeah, that's hard.
Yeah, it is. There was a comment here about when things work, you know, we take it for granted sometimes that everything's going to work just fine. And this is a tough environment. About half an hour ago, I came in and tested our heat flow probe, and it didn't work quite right. So after the sub comes up tonight, we'll swap it out for another one. We have a spare, and we'll do some troubleshooting and figure it out. But we always have to be ready for things not quite working the way we hope. Most of them have probably never seen light before. Certainly not light like is generated by the ROV. Someone asked at dinner tonight, what do the octopus see with their eyes? And we don't know. But it might be that some of the organisms here are able to see light in different wavelengths than what we see because they spend so much time as it came out. Now, we don't know about these organisms here that we've been looking at. Many of them are new to science. They've been around probably a long time on this planet, but they're not well understood. We don't know much about their natural history. We don't know, in many cases, how long they live. One thing I've been learning from the biologists is that life tends to be a little bit slower in a cold, dark environment like this. And so it's thought, for example, the octopus live a bit longer than they do in warm, shallow water here in the cold abyssal ocean.
It's not going to go. That's a piece of Carlos's artwork. Oh no, it was already broken.
Yeah, 3,000 meters. That's right. Pretty deep. Takes a long time for the sub to get down and come back, and these organisms, they have evolved and developed to live in the dark and under tremendous pressure. But it's also interesting to look at this scene we're seeing right now. There's particles of different things, but it looks like there's a lot of living organisms in the water column as well. Of course, all those critters on Dorado Outcrop need something to eat.
Come back down.
So we're going to be settling back down on the outcrop in a few minutes. And at that point we can begin to look at the samples that will be collected. Still no joy. You got it to work.
We want to try if we can see there were some chirons over there in that area, if they can go back to the same spot.
Okay.
And try
So
to
same physical location,
exactly.
ideally? Okay.
Look for a chiton.
Chiton? Okay.
Yeah, and try to
Try to pick it up?
Yeah.
You want to try to pick it up?
Yeah, the chiton.
Okay. So we're going to be headed back to about the same spot, and we'll see what's there. We're coming back to marker W, that's this work area, roughly back to where we were earlier in the dive. We see a lot of octopus. Do you have a spot you might like to?
If we come back, maybe I remember.
Just like right where we were?
Yeah.
Exactly where we were?
Yeah.
Can't do that.
So we see a lot of octopus, we've got worms, we have shrimp, these little white squat lobsters, which are, I'm told, are actually a kind of crab. We have sea pens, these sort of sticks that are anchored to the rock and they stick up and they've got polyps along their length. And we saw some amazing organisms on the way down. Yeah, many of them just don't look real. They look like they're imaginary, but they're real. The water column is just teeming with life.
We're looking for it.
So what would you like to?
We're looking for the chiton.
For a chiton. All right.
One of the armored worm looking things?
Yes.
We are looking for a chiton. That's our immediate mission. See plenty of shrimp. Some of the folks who are listening may know the history, but I'll give you kind of a brief overview. This area was discovered remotely in 2001 and 2002 using some regional survey data. These expeditions that went out about 20 years ago didn't have the benefit of a submersible or an ROV. We were just out with profiling instruments,
Sorry, can you pick up this little star here?
coring instruments, and thermal instruments, kind of mapping out the state of the seafloor. And as part of that two-part expedition, we found an area where there was elevated amounts of heat coming out of the bottom of the ocean. But we didn't know what was there. We threw down a couple of gravity cores, and several of them toppled over. And the cutting shoes came back all beaten up, and that suggested we'd hit hard rock. But we really didn't have the ability to see all of this, all of the glory of the animals and the natural environment. So it took about 10 years to get a proposal funded. We wrote 3. We finally got to come back in 2013 with a remotely operated vehicle called Jason and an autonomous vehicle called Sentry. And we dove on the outcrop and just went back and forth, trying to figure out if there was a place where water might be coming out. It took about a week. Even though this outcrop is not huge, it's about 2 kilometers long, about 500 meters wide. That's a lot of area to cover with a remotely operated vehicle. So we went back and forth, and finally, after about a week, we found not this area, but one up on the northern end of Dorado Outcrop. We found a spring and some additional sea life and so forth. But it was later in that cruise when we sort of stumbled upon this area. And, oh, there's a chitin hiding behind a sponge. Is that the one?
Is that the one? I don't know if they're supposed to. We have to ask them.
Yeah.
What do they think?
It's pretty small, huh?
It's very small.
Yeah. Is it?
What do you think?
Yeah. What's your opinion? Is it too small or too far away?
I might be able to get it. Though I'd have to move for sure to get it with the floor door.
The original focus of the.
If I pick up and move to go get it?
Sorry?
Do you mind if I move?
He's going to try to move this up to.
It's okay.
Yep. Thank you. Those early expeditions, we were looking at the geothermal conditions. We're looking at the chemistry. We had some geologists with us, but we didn't, and we had microbiologists in 2013, but we didn't have the experts on all of these animals. So one of the things that's really exciting about this expedition is getting to be out here with people who are experts in all these different aspects of marine biology. And to have them here together and to be able to talk to each other and learn about what this system means as a natural habitat. We don't know how many outcrops like this there are in the world. Estimates are somewhere between 10,000 and 100,000 seamounts and other outcrops, but these are extrapolations based on limited data. We really don't know for sure. But the number that have been surveyed in detail, like this one, you can count on one hand. This is for the deep ocean, for deep water seamounts. So it's a whole habitat that is global in nature, maybe quite important for some system services, and we just don't know much about it. So that's one of the reasons we're out here and making measurements and collecting samples, is really just trying to figure out what does it mean to have an environment like this. And it's always hard because we get a snapshot. We come down, we see it for a short time, and then we leave. So we've left instruments out in June in order to help with learning what's going on here. And who knows if we'll be able to come back. I think a lot of us would like to. There's a number of other outcrops in this area that are completely unexplored. We just don't know what we might find. Yeah, the funding is important. It's also sometimes hard to convince our peers that our ideas are valid or that we have a good chance of succeeding. Many of the reviews we got for the original proposal were skeptical. They said you're never going to find springs. You know, it's even a small feature like Dorado Outcrop is too big. You just won't have the time to survey it. So in some ways, even finding anything was a big deal. Calculations suggest that there are many, many sites like this one around the planet. Outcrops like this are responsible for extracting about 1/4 of the Earth's heat. The warm water that flows out of the seafloor here carries a lot of heat. We've estimated that for Dorado alone, the heat output is on the order of several hundred megawatts. But that heat is all coming out at low temperature. There are hydrothermal vents that are found near mid-ocean ridges, high temperature vents. A vent field there can also have a heat output of hundreds of megawatts. So this is comparable in terms of the total amount of heat, but it's a lot more water. We think there's thousands of liters a second of water coming out of this outcrop. There's a question in the live chat about results from the earlier expedition. I think a lot of the samples are just getting, the analyses are just getting underway. And so we don't have a lot to say about that. Oh, there's a little chitin that we're going to try to sample just on the other side of that sponge. So we've reset the pilots, reset the sub, try to get closer, and now with their manipulators, they're trying to collect that little fella. It's a delicate operation. We have a wide variety of activities planned. As you've already seen, we're going to be doing some fluid sampling. We'll be collecting a variety of microbiological and other biological samples. Later on in the expedition, yeah, like trying to pick up a pea with chopsticks, that's right. It's a tiny little critter. But the manipulators are really impressive, kind of like your arm. They have a wrist that rotates all around. They've got joints like your elbow and your shoulder that allow them to move. And the way the pilots operate these manipulators is they have kind of a miniature model of a manipulator right here in the control room. And every time they move their little model, it moves the titanium arm that you're seeing there. It's very delicate. And they don't get a ton of feedback. So that makes it really challenging to feel, when they've been able to connect with something, they want to grip it gently. It's quite a delicate operation. Whoa, the little chitin flipped over. So he's not attached anymore. But now they got to figure out if they can very gently pick him up. Yeah, it is. The ROV pilots are very, very skilled. Part of it's mechanical, part of it is in sort of spatial recognition, realizing where they are in space relative to whatever they're working on. Looks like he's almost got it. I was on one expedition about 15 years ago where we lost the wrench that we needed to turn a tiny bolt. And we were very impressed. The ROV pilots managed to take a manipulator kind of like this one and just grasp the very edge of the bolt and rotate it. And they actually helped us to complete our work without the right tools. They're just that skilled. Yeah, apparently they'll be checking out the suction sampler when the ROV comes back. We'll see if we can have it ready for the next dive. Hey, there it is. Amazing. All right. Absolutely amazing. That little critter's not very big, and they managed to pick it up. All right. Well done. Oh! All right, take two. Yeah, if you had to race a chitin, I think you'd probably win. So, picking up the critter is just the first step. And we call those cylinders bioboxes. We keep careful track of who goes in where. And so we have someone recording each event as our work proceeds, and they're going to take a record that says a chitin is in cylinder 1. That way we'll know when the vehicle comes back, we'll be able to make sure that oh my gosh. That little chitin is holding on. That is amazing. So now they're going to gently, and there he goes. Woo! Well done. My goodness. Well done. Okay, so you'll have to.
There's some octopus inside the crate.
Oh, in the crate?
In the crate.
Oh,
It has to be closed.
so is that crate?
We are in the same area.
Okay.
I think it's just beneath the sub.
Oh, it's just below the sub?
I think so.
What do you want next?
All right, well done. We have interest in, there's a male octopus apparently in the OsmoSampler crate, which might be just below us, I'm not sure. Yeah, so I think we'd like to sample that one.
Sample the octopus itself.
Yeah.
I'm gonna pop up real quick while you step. Actually, don't pull me still. I think I'm gonna need you to bring your arm out because we gotta get the net. Janet, you want us to go in the net? You want us to use the net, right? Do you want us to use the yellow net?
Whatever works for you.
Okay. Yeah, I think it's gonna be the yellow net. All right, I'm gonna so works out.
And it looks like our next specimen to be sampled may be one of the octopi.
All right, the yellow net is that black and yellow image. Yeah.
Yeah.
And here comes the net. Looks a little bit like a butterfly net, but made for the deep sea. Back goes the tray. That milk crate that you see right at the lower center of the screen, that contains
This one you think is awkward because the milk crate, this one's good.
the milk crate contains a long-term water sampler.
Do you think the milk crate will be in the way?
I don't think so.
Okay.
It's a fluid sampler that works for months or even for years without any batteries or power. It just runs with a gradient of fresh water and salt water. And we will eventually recover that crate, but for now we're trying to recover the critter who's hanging out by the crate.
Not that guy, right?
Right, the one you got, the one who's holding on.
Yeah.
Pardon?
Sorry, David.
Yeah.
Well, I don't know if it's like some pictures.
Yeah. So,
But if you already have it, it's okay.
Wow, amazing. Absolutely amazing.
come down with your arm. Yep, rotate it. Rotate it. There you go. All right, cool. I'm going to start bringing the torch up nice and easy.
I think I can go into 3, but.
Oh, I see it. Where?
Biobox 3.
With the clay
Bottom
pot
cell.
is?
Do you prefer biomass 3? Down 2?
2 is better.
2 is better?
2 is better. 2 is better.
2 it is.
How about you coming up?
Thank you.
You know, we're really fortunate on this expedition. We have experts in a number of kinds of marine biology, including Janet Voigt, who is one of the world experts on octopus. So she's overseeing part of this work, along with other scientific team members.
No, that's all right. It's okay. We're about to do it.
So now we would like to, since we are already up the bottom, like just look around if we can spot some corals.
Corals.
For Randy,
Mhm.
if we not see them in like in 10 minutes, we should come back because we have to be here at 8 for the light test.
Ah, right. Okay.
And then pick up the OsmoSampler and together. So
Okay. That's the one that's in the basket right there.
yeah.
Okay. Okay. But that'll be it.
And that'll
Another
be it.
hour and 15 minutes.
Yeah.
Okay.
That's right.
Hey, quick question.
So just a short ride.
Stream is just seeing this, or?
Yeah.
Switch back. Okay, what are we doing now?
So our goal now is to survey around a little bit. The biologists would like to find some corals, and we don't want to go too far because we've got about 20 minutes or so, 25 minutes. And I'm going to defer to the biologist to tell us which corals they would like. So which kind are we looking for?
We're looking for primates, and Randy's coming to.
Okay.
She's
All right.
the one that.
Randy's coming back to the control room. She's going to help to look a little bit and see if she can find the kind of coral that she would prefer.
Yeah. So bamboos have these dark nodes, and we call the organisms on them sea pandas. Pandas eat bamboo.
Go fast?
I'm looking. Yeah, I wanted to go fast.
And then that way I can get back here.
And I'll give you some zoom suggestions if we see something promising.
So now we're kind of headed uphill on the
I
outcrop.
don't want to take a lot of time because I know it sounds like from Diva and Bia that we're unlikely to find what we're looking for here. So let's give it a quick little look-see and then get you back to where you need to be so we don't take too much time. Look at that though. Half-dead sponges.
Yeah.
Anthomastus, not those.
What are the pink?
Those are mushroom corals.
Oh. But those are not the
Anthomastus is
corals
the
you're
deepest.
looking for.
No, these are not the corals I'm looking for.
Yeah. Okay. So we're going on a coral hunt.
Gonna be a big one. We're not scared. You know that story?
Can't go under it.
Yeah.
Can't go around
over
it.
There's a black coral? No black coral, right?
No black corals. I see it. Nope. A lot of great sponges. But no. Nope.
Marker F.
Marker F is definitely not sampleable.
Oh, a little octopus.
Little one. Cute.
Look at the little octopus right there.
Posed perfectly up. Can you stop, J-Rod, and go back and take some pictures of the octopus, please?
It's a tiny one, right?
So there's a relatively little octopus. We've seen some newborns. We've seen some older ones. This one looks like
Juvenile?
maybe a renegade adolescent.
Teenage octopus? Sounds like a man.
May have a lot of attitude. That one.
Oh, sorry. Do you need access? Sure.
Yeah.
All right, I think. Thank you. Did you get the pictures you needed?
Hello, indeed.
Okay. We're good, J-Rod.
No more octopus?
I mean, I think we're going to go back to the octopus in just a few minutes.
So we're still on a hunt for a particular kind of coral.
And I don't think we're going to find it here. But
May
at
not-
least we're going to get a sense of what is here, which
Yeah.
is also pretty cool. Figure out
One of
what
the-
surrounds the octopus garden.
You know, one of the things I remember from our surveys 10 years ago was that a lot of the outcrop looks like this, with sponges and sea fans and corals and so forth. So
I can't tell.
It looks hard.
it's not,
It looks crunchy.
Yeah, it
Look
looks,
at you a little bit closer.
yeah.
so it's not, we see these kinds of organisms everywhere. They don't necessarily require the warm water coming out from inside the outcrop, but they are surviving on the current and the particles it's carried.
Not what you're looking for?
No. It's great. I'm happy to have to zoom in, but no. No, I don't want to do that very first one.
Okay, looks like another bamboo.
More octopus.
Yep, here's another mini garden here out in the suburbs.
Yeah, I
Out
see
in the
it.
garden suburbs.
Do I see that sea star?
Oh,
to the
did you
left?
see the one in the hole right there?
Yep. In a cave. Another, no bamboos.
Ooh, what's the orange one there, no?
That's a crinoid.
Oh yeah.
We're flying.
I'm trying to cover as much area.
You're doing a great
Yep,
job.
and more octopus.
Amazing.
As we
There are
move up.
octopus really tucked in everywhere.
They are,
Wonder
and
if
there's probably water coming out there too.
Coming up to marker E.
I think you're probably right. I mean, why else would they?
Yeah, you all who are watching are getting a nice tour because
Yeah, it is a good tour.
we're covering some ground. Here's
Little
marker E.
exploration.
Yeah, these are all places that were visited previously. And now this landscape, this looks more like what we found over much of the outcrop 10 years ago. It's dark, it's covered with a little dusting of sediment.
Just a little light dusting.
Yeah, and
Nope.
a variety of critters, but no octopus. We'll see whether we've come across any more.
Good.
Oh, there's one.
Stars.
There's a couple
quite
octopus.
few.
Yeah,
See, there's a bunch in the back
yeah,
too.
yeah. They are scattered about.
No Nope. Well, I'm definitely happy for the tour.
There's a question about what kind of coral we're looking for.
We're looking for primnoids, if possible. I don't think there's going to be. I think it's a long shot in this habitat. So I'll just take this little tour, and we'll have a nice little survey.
What's the yellow one right there? What's that?
I don't know what's fuzzy.
Yeah.
We'll just keep going though.
Okay.
I'd rather cover more ground. That's a cool little.
Wow, look at that
what
guy.
is that?
What is that?
I don't think so.
Super juvenile?
Oh, is it a living version of like all the dead stuff around it?
No.
That's different.
That stuff is just like flock stuff.
Yeah, okay.
It could be like we could collect it.
What's
I think
that?
it'll work. We could try it. We could try it. Yeah.
We want to see this. I think it's sea urchin.
Oh.
Oh.
Yeah. Can you look for the urchin?
Oh,
That would be an interesting collection.
Yeah.
Is it underneath it?
Yeah, right there. So some of the biologists have expressed interest in there's a little sea urchin, it looks like, who's living under that yellow cluster. So we might reorient here a little bit and come back and take a look.
So you see, we're disturbing all the sediments. That's what that
Yeah,
brown
that's
stuff
what that is. Okay.
Yeah. You can see some crinoids in the back up there.
Yeah. Oh, yeah. Little-
Steve, if you're still on, that would be really helpful. I don't think that's a Christ picture.
Yeah. Looks more like a sponge, maybe.
What I'm kind of wondering, no, it's definitely coral.
No, I meant the
Yeah, I think that is definitely, I don't know, it does not look like an urchin to me. But maybe it is, and I just don't know.
Alright, so there was a sponge, but we want to collect that coral, a piece of that coral.
Yeah, I was thinking.
Yeah, so we can collect that.
Yep.
Alright, let me get set up for that real quick. Get ready with your server arm.
Can you put some lasers on it? I just want to get a sense of how big it is.
It's small. Lasers are almost.
Sorry, thanks, Andy. I didn't mean to be in your space.
Oh, it's good. It's good. I'm sort of learning how this all works.
Brady, you see lasers?
I do. I see him. And Steve is on, so if you give him a nice, good close-up before you collect it, he can help us ID it.
Oh, is that another chitin back there?
Steve, we're setting up.
Before we collect it, we should do zooming and have some pictures with the laser zoom.
Steve will help us identify if Steve asked for that. So.
Oh, yeah. Yeah, great. Seems like I was reading the chat.
Yeah. Perfect.
So the pilots have brought the vehicle right up against the edge of the outcrop. That helps us to stabilize. Now we're going to get a better look at that that yellow critter. Figure out what critters. Okay.
I'll get you a zoom in at the.
So lasers on. Are the lasers 10 or 20 centimeters apart?
10.
The lasers are 10 centimeters apart, so that gives folks
As close in as I can get you.
And there's a lovely, lovely close-up.
Well, I think maybe we'll get a close-up when it's in the minutes.
We want
okay.
a piece of it, the whole thing.
What is the size?
It was like 12 centimeters.
Are we going in the quiver?
What?
You are not going
All right, go ahead and start opening up.
I'll try it.
I think it'll be okay.
You want on the color?
If she wants to work with that, we need to go colony because it's small.
You want to try?
I'll try it.
Okay.
But
So is it okay?
That's okay with me.
Two or three, whichever one he opens up. But feel free to do 3 if you want. Which one is it? Which one what? What's that? Yeah, we'll let you know before I got there.
Golden coral, he says.
It is a Christ gorgeon. Huh.
Nice. Nicely done, Pete.
Thanks, Steve. If it's a crisis word, then I'll definitely do it.
Like this?
Is that okay?
Yeah.
I'll just take a little bit.
Go a little bit forward, about there.
Andy, if you want to tell J-Rod, I think we're going to try to take the whole thing.
Whole thing? Okay.
We're going to split it across like 3 or 4 people.
Whole thing, please.
Okay.
Thank you. So this is a specimen that a number of people on board are interested in, and it's not very big, but they're gonna make good use of the specimen and do a variety of different kinds of studies. Just getting everything set up just right. We have a question in the chat about facilities, and yeah, the ship is pretty deluxe. We've got really good labs, and of course the center of it is this remotely operated vehicle, which is quite a capable vehicle, and the whole setup here for operating the vehicle is quite good.
Perfect.
Now look at that.
Sorry guys, can you do another zooming when you have the thing?
Yeah, bring it up closer to the camera.
Really close.
Oh, because they lose their color and all when they come back. Yeah. So, you know, we would like to get these close-up images, in part because these organisms don't always look the same once they come back on the ship. They can lose their pigment, they can lose their shape. So these images that we get are very important for helping to identify and understand the nature of the organisms at the time that they're collected.
That's good?
Yeah.
Okay.
Thank you.
Good stuff.
Like climbing in the forest.
He's like, I'll take a ride.
You want to come up?
Yeah.
You will get it too.
I don't.
You'll get it. Okay, how do I list that? Is that considered one sample?
Yes, not sample.
This one sample for...
One collected on this.
Right here, go forward and start for start doing this.
That's good. I'll have something to track. And to meet for
Might be a little sticky, just so you know. So you go and kind of straight up over it.
It's interesting to think about the colors and the patterns that these organisms have. You know, we're at 3,000 meters, and when we're not here, it is completely black. There might be a little bit of bioluminescence, but by and large, there's not a lot to... there's no light that you could see by, so it's kind of a wonder. Why are some of these organisms different colors? And well done. Yeah, the water that comes out from Dorado Outcrop is about 10 to 15 degrees warmer than the bottom water. Bottom water around here is close to 2 degrees Celsius, and we've measured temperatures in some places around 12, 14, 15 degrees Celsius. So it's not super hot, but it's quite a bit warmer than the bottom water. And that makes it energetically favorable for these organisms to spend time there, because if they can expend less energy living their lives, then it gives them a better chance to survive. So now the pilot is getting the lid for this cylinder. All right. Folks, it's a delicate operation. And oops. There it is, safe and secure in cylinder 3. We're headed back to where we started the dive. Later on in the plan, there's going to be some testing of lights and camera equipment. And then after about an hour or so, we're going to pick up that basket that had the OsmoSamplers and temperature logger, get those stowed. And then that'll do it for this dive. This was kind of a short dive today because we got here and put the sub in the water right around noon. We're running a little bit later than is normal, but it was still kind of a short dive. But hopefully, if all goes well, we'll have regular dives in the coming days. We tend to launch the sub at 5 a.m., on bottom by 7 or 8, and then we tend to bring the sub up around 5 p.m. Please come off the bottom, have it on board in the evening, and then recover the samples, get everything turned around. Randy? Oh, okay. There was a comment here about checking that.
Okay, I'll tell her.
Yeah.
Okay. Yeah, we're bringing that in soon, so I'm going to do a sign off because we're going to turn the live stream off.
Sounds good. Thanks for joining us. I hope we'll get to see you again on some more dives on this expedition. Stay there.
The place where we started on this first dive. This is Beth Orcutt. Thanks for tuning in for this dive. It's been fantastic. We are going to be turning off the live stream now for some filming with the BBC. So thanks for tuning in. We're going to have another dive coming up tomorrow. We'll be visiting the second octopus nursery in this location that we know of. Hopefully we'll be in the water at 5 a.m. Costa Rica time, on bottom around 7 a.m. So that'll be it for today. And thanks